Cody, I welcome you to the session.
Thank you.
So tell me, Cody, why one has to learn AWS DevOps and why specifically AWS for DevOps?
Okay. So the first question is obviously why AWS DevOps, which is obviously a frequently asked question. There are so many other DevOps tools, and why to choose AWS DevOps is because AWS is a highly reputed firm for what they do and what cloud services they provide. And basically AWS DevOps is a set of developer tools which
Hey guys, I welcome you all to the live session on AWS DevOps full course by Intellipaat. Today we have our colleague who is also a cloud enthusiast and who has helped us in curating this video of the day. Let's meet him and ask few questions about AWS DevOps. Hi Cody, I welcome you to the session.
Thank you.
So tell me Cody, why one has to learn AWS DevOps and why specifically AWS for DevOps?
Okay. So the first question is obviously why AWS DevOps, which is obviously a frequently asked question. There are so many other DevOps tools, and why to choose AWS DevOps is because AWS is a highly reputed firm for what they do and what cloud services they provide. And basically AWS DevOps is a set of developer tools which provides us every single tool in order to automate the entire software development lifecycle. And the second question was why AWS specifically for DevOps? It is because AWS is again the largest cloud provider in the world. The number of services they provide and the reliability using those services are much better than the other cloud providers. And to use AWS DevOps and combined with AWS, that basically gives us better reliability and a better performance in our company. And also why AWS for DevOps, there is another type of an answer which basically talks about the career opportunities, as again AWS is the biggest cloud provider and thus the career opportunities are in abundance and also with a great pay.
So guys, let's see the next question. So Cody, tell me, how can an individual or a company get benefited by learning AWS and DevOps?
Okay, so looking at the individuals, you don't need any guidance to start off with AWS DevOps because all you need is an AWS account. You don't need to pay anything to start off with AWS DevOps. And as I told you, it is a set of developer tools which combines all of the tools which need to put together a complete software development lifecycle. And when coming to a company, any company wants to automate any tasks they want. For example, if there is front end, back end, whatever it is, a company wants to automate every single task they have. For example, if a developer codes, then uploads it, and then a tester downloads it, and the tester basically tests and puts the code back again by pushing it, and then again another person reviewing it. So this will take a lot of time. So now when it comes to DevOps, the only process where people are involved is the starting, planning, and the coding part, and then basically everything is set up and everything is automated. That basically can reduce the time a company works on a particular project and can give the product to the customer even faster than before.
So guys, let's see the next question. Cody, we all have heard about popular DevOps tools like Jenkins and GitHub. What are the alternatives of these tools in AWS DevOps?
Okay, so if you look at GitHub, it's a version control tool. So like that, in AWS DevOps, there is a tool called CodeCommit, which is especially for this purpose. CodeCommit is a version control tool which you can start off with. And comparing to Jenkins, so Jenkins is a CI/CD tool which we can use to automate or build and release cycles. So in AWS DevOps, we have a tool called CodePipeline, and also there is a tool called CodeDeploy, which we can combine and use for both building the tool, deploying the tool, and finally releasing it to a server. So these two are the alternatives to GitHub and Jenkins. So to cover other tools, there are other tools as well. For example, there is CodeBuild, especially for building, and there is artifacts to store the created artifacts, and also, as I told you, CodeCommit, CodeDeploy, and CodePipeline.
security, management, customer engagement, app integration, etc. So we're going to discuss each one of them one by one as we move along. So first up, the compute domain or the AWS domain is compute. Alright, so I think I have a question from Shubham. So Shubham is asking me, among these domains, what is the difference between storage and database? Alright, Shubham, so storage is basically used when you have a workload wherein you want to upload binary files. Like, what are binary files? Files which like video files or MP3 files or photo files. All these files are called binary files because they're not data. It's basically, it's content, and that content is basically binary in nature. All right. So all your videos, all your music, right? Any kind of file which you execute, your games, all of those are binary files. When you compare it with database usually deals with data which is textual in nature and has a proper structure. It could be unstructured as well, but basically textual data that a human can read is included inside a database, right? But on the other hand, files that run on computer, for example, any program or any video file, any music file, or any other file in that case, these kind of things cannot or should be stored on a storage kind of platform. It should not be stored on a database. It can be, but it should not be, because it unnecessarily makes the database, the size of the database big, which actually causes a problem when you're querying through the data when you're using a database. Alright, so guys, this is the difference between storage and database. Shubham, is your doubt clear about the difference between storage and database? Alright, so I've got a yes from Shubham. Others, guys, if you have any doubts in these domains, you can ask me. Let me explain you all these domains one by one. So compute domain basically deals with servers. So if you need servers, or if there is a workload which needs processing, the compute domain will have services that you can launch and implement that workload. More on this we'll discuss as we move along. All right. Then we have the storage domain, which, like I said, deals with storing binary files on the remote servers. So for that, we have a dedicated services, and we're going to discuss those dedicated services in storage. Then we have a service called database, a domain called database. In the database domain, you have a lot of services. So if you have structured data, you have one kind of database for that, or we have one kind of database service for that. If you have unstructured data, you have another database service for that. So we'll discuss more on that as we move along. Then there is a domain called security. So all security related to the application that you have uploaded, to the servers that you're using, to the account that you're using, for all those kind of things would be included in security. So there are specific services for each kind of workload that I just mentioned. We're going to discuss that when we reach the security domain. Then we have the management domain, which would include monitoring, which would include deploying the whole architecture at once, right? All those kind of services comes in management. Don't worry if you don't understand it. I'll explain you more as we move along in that domain. Then we have customer engagement. So sending emails, sending notifications, all those kind of services comes under customer engagement. And in the end, we have app integration. So services like queues, like for example, if you have an application on which you have to give a lot of jobs, it's better to have a queue where you'll store all your jobs, and that queue is separate from the server which will be executing your jobs, right? So these kind of integrations are called app integrations, and we'll be discussing the services in that domain as we move along. All right. So guys, these were the domains, the main domains that are there in AWS. There are a lot of other domains as well, but we'll be focusing more on these domains since, this is what is actually going to be asked for in your solutions architect exam. And at the same time, these are what you will generally be using when you become an AWS engineer. All right. So moving forward, guys, now let's start with the compute domain and let's see what all services are there in the compute domain. Alright guys, so let's discuss the AWS services in the compute domain. So here are the set of services which are included in the compute domain of AWS. So this particular service is EC2, Elastic Beanstalk, Lambda, Autoscaling, AWS Load Balancer, AWS ECR, and AWS ECS. Now for the sake of explaining you guys, I've taken the liberty of shifting some services from some other domains which I think should fit in this domain, right? But you don't have to worry, the explanation would be the same. It's just that you would find it somewhere else in the AWS Management Console. Like for example, auto scaling would not be under the compute domain, it would be under some other domain. I'll show you when we move on to the AWS Management Console as to where you can find each and every service. For now, guys, let's start with the first service, which is AWS EC2, and let's see what is it all about. So guys, Elastic Compute Cloud is nothing but a server. It's a raw server. It's just like a fresh computer that AWS gives to you. So what you basically do is you ask AWS for server, right? And that service is called EC2. So what you do is you specify the kind of processor that you want, you specify the kind of RAM that you want, and then you click on launch. And what happens after that is you get a server which is basically of that exact configuration. Now what you will have to connect to it remotely. So if it's a Linux machine, you will connect through SSH. If it's a Windows machine, you will connect through RDP, right? And once you connect to it, it'll give you the UI of how an operating system actually is. If you installed it on your local, it'll be exactly the same. It's just that now it has been basically launched on the infrastructure of AWS, and that can be accessed using various tools like the RDP tools or SSH tools. I'm going to discuss more about EC2. I'm going to basically launch an EC2 instance in a moment. But before that, let's discuss all the services which are there in compute, and then we'll do that EC2 demo as well. Like I said, it's just like a raw server that is given to you. And on this raw server, you can install anything, you can make it anything, you can basically build it, make it a web server, you can make it a database server, it can be anything, right? That is what EC2 is all about. Now in the diagram, as you can see, you can launch either a single EC2 instance or you can launch multiple EC2 instances. You also have an option of launching, of creating a EC2 instance and then installing some softwares on it, and then you can launch multiple copies of that particular EC2 instance, so that you don't have to launch, or you don't have to specify, or you don't have to install all the softwares all over again. You can create multiple copies of the EC2 instance again, right? And at some point of time, if you feel you want to increase the configuration of your system, you can also want to make it 16 GB. Even that is possible in EC2. And that is why the name is Elastic Compute Cloud. Elastic means that you can increase the size of the instance or decrease the size of the instance configuration as and when required, right? So guys, this was about Elastic Compute Cloud, that is EC2, right? Our next service is Elastic Beanstalk. Now Elastic Beanstalk, guys, is an advanced version of EC2. How is it an advanced version of EC2? In EC2, what you could do was you could just launch a server, right? And then you can install softwares on it. You can make it a database server. You can make it a web server. You can make it anything, right? With Elastic Beanstalk, you get certain restrictions on EC2, and there is a certain amount of automation involved. So what is Elastic Beanstalk exactly? Elastic Beanstalk basically is a web application server, right? You cannot install any other software on it. It is a web application server on which you can upload your website, and you don't have to install any software. You don't have to do anything. Like I said, we talked about what is infrastructure as a service and what is platform as a service, right? So infrastructure as a service is EC2, okay, where you get the whole server, you get the access to the operating system, etc. Elastic Beanstalk is platform as a service. So in this, what you get is a dashboard. You don't get access to the operating system. You don't get access to the softwares that you have to install on that server, right? Everything is pre-configured. All you do is you say that I need a PHP server. It'll launch a PHP server and it'll give you a dashboard where you'll have a upload kind of a button. You click on that upload button and you'll have to put or upload your website over there. So once you have uploaded your website files, they automatically go into the path where they have to go. And all you have to now do is just go to that IP address or the domain name of that particular Elastic Beanstalk instance, and you will be able to access your website. If you compare it with if the same thing you had to do on EC2, you'll have to first install the softwares, then you'll have to upload the file using FTP because there's no dashboard to upload it. So you'll have to download an FTP client, connect to the instance, upload your files like that in that particular folder. And then if you go on to the IP address of the EC2, only then you'll be able to access the website. With Elastic Beanstalk, what they did was, like, if you have a use case where you have to deploy a web application, You don't have to do all that manual stuff of installing the software, of installing or putting your files on the server. All you have to do is you have to open Elastic Beanstalk, select the environment that you want to deploy, and upload your website over there. That's it. Right? So it's an automated version of EC2 in which you have certain functionalities of putting a website over there, but there is a limitation that only it can be a web application server, right? It cannot be a backend server for you. Elastic Beanstalk is only used to deploy your websites. Guys, remember that. Because the next service of ours is a little different from Elastic Beanstalk, right? And it also has some limitations. Our next service is AWS Lambda. Now, AWS Lambda, again, guys, is an automated version of EC2. It's an advanced version of EC2, but with some restrictions. Now, what are those restrictions? It cannot deploy an application. You cannot upload your website on it, and it cannot host an application for you. What is AWS Lambda? AWS Lambda is basically just used for doing your backend processing. Now, what is backend processing, you might wonder. So let me give you an example. Let's say you have an image processing application. So what do? You have a UI or you have a website through which you can upload an image. And what that website does is it stores the image on its storage, and then it reduces the size of the image, right? And then you can download it again. Now, you might be wondering, this is one website, so ideally everything should be happening on one server in this case. But that is not the case over here, guys. So what happens is your web application is on a separate server. The processing happens on a different server, right? And AWS Lambda specializes in processing. Now, why is AWS Lambda preferred for processing is because when you launch a server, guys, you have to select the configuration that you want, right? You have to select the processor, you have to select the RAM. With AWS Lambda, you don't have to specify any configuration. You don't have to choose what server size should be for my application to cater to the workloads that are coming in. AWS Lambda, what it does is it sees what kind of workload it is being given. It automatically scales up if it has to in terms of its configuration, and then executes all your workload and gives the result to the server, which is the web application server, where it has to give the result. Basically, only processing happens on AWS Lambda to go on, right? And that is exactly what Elastic Load Balancer is all about. So Elastic Load Balancer, what it gives you is, it will give you one domain to go on, or it will give you one IP address to hit on. You hit that IP address and Elastic Load Balancer will automatically analyze where to send the requests. So the Elastic Load Balancer constantly keeps a check on all the instances which are running in your cloud environment, and it sees which of them are healthy and which of them are unhealthy. If there is a server which becomes unhealthy, what your load balancer will do is it will stop routing traffic to that particular server, right? And it'll start routing server to your traffic to other servers. And this is the main job of Elastic Load Balancer, which is to distribute traffic among all the healthy instances which are out there, right? Also, one more important thing over here is, guys, if all the three servers are functioning in the healthy state, what will it do in that case? So it will distribute the data equally among all the servers. Now you might be wondering, how will that help? So let's say I just have one server over here with around 16 GB of RAM and let's say an i5 or an i7 processor, right? So it will be able to serve a limited amount of users. Let's say there are 10 people, right? So who are there on the website. Let's say the server will be able to serve 10 people. Now what happens if there are 20 people tomorrow? In that case, you always have to plan ahead and you have to keep more servers in your group, so that, or in your architecture, so that if there is more traffic, my requests can go on the other servers, so that the load is actually decreased on the first server, right? So what load balancer does is it will never make one server max out on its performance. It will always distribute the traffic equally among all the servers, so that the processing or the overhead on any server does not go up and my application should not become slow, right? Now you might be wondering that how do I constantly keep a check on how much traffic is coming on my website and accordingly deploy servers? So that answer I will give you in my next service, which is AWS Autoscaling. So what is AWS Autoscaling? It automatically scales up the number of servers based on how much traffic is coming onto those servers. Now, how does it do that? You can set a certain threshold. Let's say there are 4 instances which are running on my architecture. So what I can teach autoscaling is that whenever the collective CPU usage goes beyond 80%, launch one more instance in the group. And the load balancer should now route the traffic to the new instance as well, right? So this is what autoscaling is. Similarly, when the CPU usage collectively goes below 40%, let's say, decrease the size of my fleet, decrease the size of my server fleet. So in that case, what I'll do is at the moment the collective CPU usage goes below 40%, it will decrease the number of instances in your autoscaling group, right? And that's how it works, guys. And the autoscaling service cannot exist alone. It always has to work in conjunction with AWS load balancer. Why? Because if the size of the fleet is increasing, if the size of the fleet is decreasing, there should be an entity on top of it which will distribute the traffic equally among all the instances, right? So if you are making use of autoscaling, you will always make use of AWS load balancer. On the other hand, you can just make use of AWS load balancer and you might not want to use autoscaling. That is fine. But if you're using autoscaling, you absolutely have to use a load balancer for your traffic routing. All right. So this is what autoscaling is, guys. Our next service is Elastic Container Registry. Now, what is Elastic Container Registry? For this, guys, you have to know what Docker is, right? So if I have to give you a brief about what Docker is basically a tool using which you can launch operating systems in the minimum size possible. So the minimum container size that I know of is 40 MB. So what you can do is, let's say we were talking about distributed computing, right? So in distributed computing, what happens is each of your server plays a different part in your application, right? So similarly, what we can do is we can launch containers. Now what containers do is they act as a virtual server, right? But they take the minimum resources possible. They take minimum space possible. Like I said, 40 MB is the size of a container which holds an operating system, right? So in those containers, you can deploy applications, okay? And these applications then run as if they were running on a separate server. They are isolated from the operating system on which the container is running. I'm sorry, guys, if I cannot go in depth of what Docker is right now because it's altogether a separate topic, but you can understand it like this, that it's basically a mini virtual computer that you can run in your system. And ECR service, basically what it does is it stores these containers in a repository. Like you have GitHub for storing code, you have ECR for storing your container images, right? For example, like I said, operating system 40 MB size, the image has to be stored somewhere, so it will be stored in ECR. Now, if you want to run those images, you have a service called ECS.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Subscribe to Intellipaat. Now, let's continue with the session.
So what ECS does is it runs any Docker image on the AWS infrastructure, right? And it orchestrates it in a way so that if there is anything wrong with that container service can again be launched. Now, don't get confused, guys, with what we do in EC2. Now, you might have a question that I can launch multiple EC2 instances. In spite of that, why don't I launch just multiple containers? Because in that case, what will happen is you're still the machine on which the containers are running. That becomes node point of failure. That means if there is anything wrong with that machine, any number of containers which are running on your particular system will go down, right? So this is also a redundancy that you can make in your architecture, that you can also run applications on containers which are running on an autoscaling infrastructure. That is a machine on which Docker is running. But if the processing or if the CPU gets an overhead, and the CPU processing increases, you can scale your machines and you can scale your containers as well, right? So if it's a little complex for you guys, you can just ignore this service, which is ECR and ECS. It's only for those guys who understand what Docker is. So guys, ECR is nothing but it's a repository on which you can store container images, and ECS is nothing but a service to run your Docker containers. If you don't know guys what Docker is, I'll just give you guys a link after this class. It's basically a video for introduction to Docker. It's a half an hour, 45 minutes video. You go through that, and then again you can go through this recording wherein you can find a description for what ECR and ECS is, and that'll make more sense to you in that case. All right. So guys, we have discussed ECR, we have discussed ECS. Alright guys, so moving forward now, let's go ahead and do some hands-on. I think it's enough of theory for compute. Let's go ahead and launch some compute instances in AWS. Alright, so what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. Alright guys, so the first thing that you would be doing is heading on to aws.amazon.com. Okay, so once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some pseudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat-test, right? We'll click on continue. Then it'll ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give boot 1 2 3 4 5 6 7 8 9, and the country or region, you can select any region that you are in. Your address, the city that you are in, postal code. So let's say the city is Bangalore. State, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number, right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? It's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS guys is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS guys, next thing would be to basically log in, right? And for that, you'll have to, once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address through which you want to connect. 1 second, guys. So this would be the email address that I want to enter, followed by the password, and this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. Right? So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS solutions architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have Ground Station, Security Hub, Artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications, right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. Alright, now what we wanted to do was we wanted to launch our first server, and for that there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2, so I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that, and now this link would basically open your EC2 dashboard. Right? So from here you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service, and that will be in the further sessions that we're gonna have. For now, just understand how to launch an EC2 instance, and for that you just have to click on this blue button which is here which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. You have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay, so let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from, right? But the only server that is free for you would be t2.micro, okay, which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS. Okay, so you would select t2.micro if you want to be under the free tier and not be charged. So just select t2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default it's 8 GB when you're launching a Linux instance, so we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something, then the department to which this instance belongs to is there. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol, so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule, I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is the message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being launched. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test-Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's the software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It will take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay. So once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this.
Okay guys, a quick info. If you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch your Putty software, right? This is my Putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part. Now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH. Then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it'll give you a message that this server host key is not cached in the repository. Just click on yes on this message. And now you will see the screen which says login as, right? So now, since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter, and now it will verify the key that I inserted, and it'll be able to connect to the putty, to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay, so you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this. Right, t2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. All right. So we'll click on review and launch. And now we'll select the same key pair which was there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right. So let's name this instance as Windows. All right. And now in order to connect to it, this is the IP address that you get. Now just click on actions. So select the machine that you have to connect with. Once it's launched, you would be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect. And this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator. And if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch. But this is the way you get the password. Okay. Now, if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here. Right. And once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state, and then we'll just enter the password here and click on OK, and let's see how it goes. Alright guys, so let's try now. So I'll just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this, PEM file will work. So I'll just enter the test intellipaat.pem. Remember, the PEM file will work and not the PPK. Let's click on open. And now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance. Let's paste it over here. And now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay. Just click on yes. And now you should be able to connect to your server. So here you go guys. Here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything. Okay. So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard? Look for Elastic Beanstalk. Right, so as you can see, it says welcome to AWS Elastic Beanstalk, and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host application. So let's give it an application name. Let's say it's test. Okay. And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET. I can put my web app in Go. I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these were all the settings that you had to do, guys, nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this, guys, you will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it, and only then I'll be able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL, which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy and just I have to choose a file, click on deploy, and that website will get deployed automatically over here. I will just go to this link, refresh it, and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. Alright, so when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have kinesis, firehose, log to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares and then you'll be able to do that job. So I guess hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Auto scaling and load balancing, we will do it as we move along in the sessions because that requires you to know a little bit more, right? So let's move on and come back to our PPTs and let's start with our next domain now. Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, you know, it was a file before and now it's an object. Object basically is at the back end. That is how you store a file, is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application, can still be working. Okay, so Amazon S3 is a file storage system by AWS, which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that, you know, your service is going to fail. Otherwise 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that AWS guarantees that your object will have. And obviously you can increase this SLA, this basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, you know, from the vaults and then store it back again in the bucket. But that is only when you have failure in the S3 service, and for that I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists, you can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket, and you will be able to host static websites in that case.
Just a quick info, guys. Test your knowledge of AWS by answering this question. What are the different types of instances? A. General purpose. B. Computer optimized. C. Storage optimized. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Alright, our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is the Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service, and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that, there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS, and you feel that you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture, where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS that ways. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed was under storage, which was S3. So let's click on the S3 link, and that will give you UI which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next. Leave everything at default, and now let's just click on create bucket. Alright, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures, and then let's try to upload something. Let's go to documents. let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It will now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3? You want to archive the data, put it in Glacier? All those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here. Right now, if I select this file, I can actually see the properties of this file via this link. Right, here's an object URL that you get. If I click on this object URL, it will say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions, and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm, and my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions, and now I'll give public access. So I want to give read object to everyone. Let's click save. Now, if I go to the website, hit refresh, I can see the image over here. Now, this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website, and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. All right, guys. So now let's start off with EFS. So I'll just click on the EFS service on my AWS management console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember, guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step, right? Leave everything at default, guys. Don't touch anything else. Let's create the file system now. Alright, guys, so my file system is now being created. Now remember, guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that by You can check it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here to basically connect to these two instances. Right now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here, and now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is the security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you will be doing is you'll be going to networking, you'll go to actions, go to networking and click on change security groups. So as you can see, it is only launch wizard 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command and my NFS common package will install over here. Right now what I can do is I can create a directory on my first instance. Let's the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test 2. Okay, now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter. Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test 2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test 2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do an ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, if I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we have successfully discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elastic Cache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It will make sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is it also takes care of any security patch which has to be applied on your database if you enable automatic updates, right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB, or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports. It itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elastic Cache. So Amazon Elastic Cache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server, or the server from which the information is being requested. What happens is, let's imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens? Your server is again and again doing a query on the database using a particular query that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elastic Cache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elastic Cache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now, what happens is, big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is they create multiple users with restricted permissions. Okay. So each user can have their own user ID and password, but basically they will be logging into the same AWS account. And that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS Management Console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now, what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you'll have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now, what is an application account? Let's say I have a website which can upload data to S3. Now, how do I authenticate my website to upload data on S3? For that, we have the AWS IAM IAM service, using which I can create application identification keys as well. So what you get in that case is you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise it cannot, right? So this is one of the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right, moving forward guys, the next service is KMS. KMS means key management service. So key management service is basically used to create the key pairs that we saw while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. Alright, so this is our next domain guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation, then we have AWS OpsWorks, then we have AWS CloudTrail, and in the end we have CloudWatch. Now what is AWS CloudFormation guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay, so let's say I have launched two EC2 instances with a load balancer with in an auto scaling group which is connected to an RDS instance, which in turn is also connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in one particular region, I want to replicate it across multiple regions. So in that case also CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS OpsWorks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS OpsWorks, and what you can do is in AWS OpsWorks, what happens is there are multiple layers that you have to configure, and all these layers together they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how OpsWorks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say MySQL on, let's say 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So OpsWorks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in OpsWorks. Now don't get confused with CloudFormation and OpsWorks, guys. CloudFormation is used to deploy an architecture. OpsWorks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so and also it's not just a one-time deployment that you'll be doing through OpsWorks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using OpsWorks. All you have to do is just go to that layer where you have specified the link and the password, just change that, and update or deploy the OpsWorks architecture, and then in that case it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes which are very important and have to be same across all the servers, I use OpsWorks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, AWS CloudTrail should log each and every action which is happening. And it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it. And then that log data, basically, you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now, what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure will take very less time to just configure my CloudWatch to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now, what kind of alarm can it trigger? It can either email you, or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay. Moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now, this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address. It will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES. Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, we'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Subscribe to Intellipaat. Now, let's continue with the session.
So there are 2 services basically, guys. One service is called Simple Notification Service and the other one is Simple Queuing Service. Let's see what these services are. So the first service, which is Amazon Simple Notification Service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now, that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to SNS, right? So SNS will detect the type of notification received and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay, so based on the topics, the messages are filtered, and what you do is in the topics you will define which service to basically trigger, and based on that, those services will be triggered, and the services to be triggered are basically called subscribers. Okay, so guys, this is how an SNS service actually works. Moving forward, now let's look at the simple queuing service. Now, what is a simple queue service? It's basically a queue it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay, what it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether it has already sent an email to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. All right, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS. And if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay as you go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. Alright. The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get for instance is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS which says pay less by using more. Alright. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. Alright, so that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case, it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances. All of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price. But up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now, it is particularly helpful for people who are trying out AWS or people like us who are trying to learn AWS for our future careers.
Okay guys, a quick info. If you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. Alright? So the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you are running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details for. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free. And the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So in any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team, and the second team is called the operations team. Right? Now, what is development team and what is operations team? A developer is basically a person who develops the code, right? He would develop the code, and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement. Right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy, the operations guy's system could not run the code which the developer has forwarded. Right? So obviously the developer would have tested the code that he is sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it. Right? But it did not run on the operations system guy. It could be the problem of environment. It could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, you know, your code is not running on my system. Please check your code. It is faulty. Right? But now the developer was furious. You know, it ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team. Right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology. right? And this was solved using DevOps, right? Now the DevOps is what is DevOps exactly? It is not a tool, it is not a software suite. It's basically an idea, it's basically a thinking. And this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as you saw in lean methodology, where we have eliminated everything. We have tried everything in our hands to solve it using the planning part, but there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? And then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about waterfall, agile, lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology, that we are doing smaller release cycles. DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. It's a release cycles and hence releases software in even lesser days than or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that, reason being we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for an year, what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. So guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool. It is not a software. It's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which, as you can see in the diagram, that the first thing that you do is you plan what you have to do, right? Then you code your way in, then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities. And if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase, where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be, you know, the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now comes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you know, you're operating the software or you release the software for internal employees to see whether you know, the traffic, when is it doing good when it holds when it's getting traffic onto it, is it doing good when normal people are doing arbitrary tasks on your software. And then you are also continuously monitoring it to see if you know, your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring again comes the planning phase, which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys, is by automating this life cycle. Basically that means that now the developer does not have to give the code to the ops guy. It will basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency, there is no problem for configuration management. Everything happens automatically in this life cycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides we're going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps life cycle actually works, right? So if you were to that infinity sign that we had, it if you were to condense it, or if you were to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developers side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developer's side to this side of the operator side, and this is done using continuous integration. Now what is continuous integration we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay. So this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, now either if it's on the production server or if it's on the testing server. Now if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem, and also the users are saying that, you know, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay, so in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN. Right now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version and at the same time it also holds on to the previous version so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN, and continuous development is an integral part of pushing code to your version control system. Okay, now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another, and that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares and system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a lifecycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system. It is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we will get an introduction to all the tools which basically come together to create a DevOps.
Just a quick info guys. Test your knowledge of AWS by answering this question. What are the different types of instances? A. General purpose. B. Computer optimized. C. Storage optimized. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Why do we actually require the IAM service? So guys, the IAM service basically helps us to give granular permissions to people who are making use of a particular AWS account. So what happens is when a company basically is making use of AWS, they have one account, and everybody in their company who wants to use AWS, they create multiple users in that same account with specific permissions so that they can make use of AWS. Now, why is this required? This is required because obviously you cannot give administrator access to everyone, right? So somewhere in the testing team, if they just need to access the database, they will just get access to the database service, right? Somebody from the content team, if they require only access to storage, they will only get access to storage and nothing else. So all these are permissions, all these are granular permissions that you can set up in IAM and you can allot to users. But it is not only limited to that. What you can also do with IAM is give machines permissions to basically do stuff, right? For example, AWS is all about deploying servers, right? So you can give permissions, specific permissions to servers with respect to how they can make use of other services on AWS, right? And in today's session, we are basically going to explore the same thing. Okay, so how does IAM or how does AWS IAM basically work? So like I said, IAM basically can do two things for you. It can grant permissions to either users or it can grant permissions to machines, right? So we are going to have a look at an aspect of understanding both the things, that how you can grant access to particular users, right? And how you can grant access to servers in AWS. So let's go ahead and get started with the first thing, which is IAM users. All right, guys. So this is going to be a very hands-on extensive session. So what I'm going to do is I'm going to strictly go ahead and jump onto my AWS management console, guys. This is how it looks like, right? And what we are interested today in is the IAM service. So what I'll do is I'll search for IAM, go inside it, and this is how your IAM dashboard is basically going to look like. So it's going to load up in a minute. Give it a second. Yes, so this is how your IAM role or IAM dashboard basically looks like. Now, I already have some users that I've added because this is also a corporate account that we are using, right? So there are multiple people who are added into it, but let me show you if I want to add a new user. Right now, I'm basically logged in through my account, right? So I want to give this company's account to, let's say, a new joinee. So how can I go ahead and do that? Right. So first of all, what I'll do is on the dashboard, I'll click on users. And then what I can do is I can click on add user. Okay. So let's say the new joinee who has joined is an intern. So we'll just type in intern. Okay. And this intern basically wants to go ahead and access the management console. So we are going to give him the management console access. Now, this intern is also developing applications, and hence he's going to use his applications to connect with AWS services as well, right? So he is going to need programmatic access as well. What exactly is programmatic access? I'll give you a hint in a little while, but let's say these are the two permissions that we have to give. He wants to access the console. This is the console that we are accessing. And at the same time, he also wants that the application that he is developing should also be able to interact with AWS. Okay, so let's go ahead and create this user. You can also set a custom password for this guy, right? If you want, or you can have AWS create a password, auto-generate a password and give to you. Okay, so here you also have one more setting where it says user must create a new password. So whatever auto-generated password you're giving to the user, when he is going to log in, he will be asked to create a new password. If you uncheck this option, he will not be asked to create a new password. Okay, so we're gonna leave everything at default, click on next. And now this is the most important part, where basically it's asking what what permissions do you want to give to the user. Okay, so what I want to do is I basically want to go ahead and give him some permissions. So what permissions do I want to give him? So do I want him to be a part of any group? Not really. So what I'll do is I'll basically just create the user for now, and I've not given him any permission as of yet. Okay, we have created this user, and we have got, for programmatic access, you get these two things. You get the access key ID and you get the secret access key. So let me copy this very quickly. This is my access key. This is my secret access key. And this is going to be my password. And at the same time, I have this link that I will be going on in order to log in, right? And this is the username. So these are all the things for my user. I can close this now. And now what I can do is I can just go inside this user, and now we can go ahead and give him permission. So I click on add permissions. And here you can find a list of existing policies which AWS gives you by default. Okay, so here are all the different kind of policies or rules over which the permissions to this user can be given. Right now there are no permissions to this user. If he logs in, he will not be able to see anything, right? So for now, let's not give him any more permissions. Let me show you how this guy can log in. So he will first have to go to this link. Right, so we can go to this link, and here it will basically ask the username and the password. So it will load up in a bit. Okay, it's asking us the username. So username is intern, and the password is what we got from the dashboard. Sign in. And now when we sign in, it will basically ask us to change the password. So let's change it. So this is my old password. This is my new password. Okay, remember guys, I have not given this user any kind of permissions. So now when I log in, I will be able to see the dashboard. But let me show you what happens when I try to access any service that I want to use in AWS. Okay, so this is a new user. This is the name intern. This is a user that we have got created. And now let's say I want to go ahead and make use of the S3 service. So if I go inside S3, you can see that I will not be able to see anything. See, it says access denied, right? Similarly, any other service also, if I go to, let's say if I go to EC2, see, it says API error, which basically means access denied. Okay, now let's give some permissions to this user. Let's say he's a content guy and he's frequently going to use the storage service, which is S3. Okay, so let's try to give him the S3 permissions. So I'll just give him S3 full access. This is the permission for that. We'll review, click on add permissions. And now if I go ahead and I refresh this page, notice something. Immediately, this guy is now able to see all the S3 buckets, right? And he can create a bucket, he can do anything now over here. But if he still goes to EC2, he will not be able to access it. Why? Because we just gave him S3 access. We did not give him EC2 access, right? So in EC2, he's still getting permission errors, but in S3, he can go ahead and use the service just like that, which is great. Okay, so this is how you create a user. Now we have created a user, we gave him some permissions, but when you're working for an organization, it can become a little difficult when you are basically giving permissions to a large number of people, right? So for that, AWS has also thought about it, and they have given us a feature called groups, right? Now in groups, what happens is you can create a new group. Let's say I create a group name called Hello World. And to this Hello World group, let's say this is, or let's give a team's name. Let's say this is the HR team. And the HR team basically will have access to EC2. Okay, let's say these HR teams should have access to EC2. So we'll create a group, and the HR team has now been created, right? And now let's say this intern who came in, his internship is complete, and he is now going to join the HR team.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Right now, for this intern, he's not only going to work on S3, but he's also going to work with HR team. So hence, he needs access to EC2 as well. So now for this intern, all I have to do is I'll just select this intern. I'll add him to the HR group. Okay. Mind you guys, I'm not giving him any permissions. I'm just adding him to the group. Right. And the moment I add him, right, now let's see what happens. So if I go to EC2 now for the intern account, I will no longer get all the errors that I was getting. Why? Because this guy is now part of the intern group, or sorry, the HR group, and anybody who's part of the HR group is going to get all the permissions on which that group has been defined on, right? So this guy not only has access to S3, but he has also access to EC2. Okay. Now, one important thing that you have to remember over here is that any other person that I'm going to add to the HR group, he will only have access to EC2. He will not have access to S3. The only reason this guy has access to S3 is because I have specifically told in the permissions that he should have S3 full access, right? If I remove this, permission from his, and this is how you remove the permission. You just click on permissions, click on the cross, right? And now the permissions have been removed. So now if I go to S3, you will get access denied. And you will only have access to EC2 now. You can see S3 is getting access denied. And again, if you want to remove someone from the group, all you have to do is go to the group. Let's say this is the user which we have added. Remove user from group. He's been removed. And now if he goes back to EC2, this account is back to nothing. This account again has no permissions. All right. So guys, this is how you can basically create a user, add permissions to that user, add him to basically a group, add permissions to a group, and remove someone from that group. This is how you can work with the user. So this user can, now I've told you everything which this user can do on the management console. Now this guy can also work with his programs, right? So whatever permissions are given to this user, his software also has the same permissions. For example, let me open the terminal. So let's make use of the AWS SDK. Okay. So what I'm going to do is this is the AWS CLI. So what I'm going to do is I'm going to configure the CLI to make use of this particular user. So here I will require the access key ID, which is this, and the secret access key, which is this. So this is a programmatic way of accessing AWS. But like I said, the permissions is always going to be the same. Okay. Now let's say I want to go ahead and list all the buckets which are there in my S3 server. So if I do in AWS S3 LS, it should list all the buckets, but right now this intern user does not have any permission. So it says access denied, right? But what if I go ahead and give this user permissions, right? So what I'll do is I'll go to users and I'll go to intern. I'll click on add permissions, attach existing policies, and now let me give him S3 full access. So now this guy since has S3 access, if I refresh the command, you can see I will be able to see all the buckets that are there in S3. Why? Because now this user has the permission. So my intent over here to show you is that whatever you do at a central place in your IAM service is going to have an impact on his software, where he's using this access keys and the secret access keys, and also his user through which he's logged in into the management console account, right? So IAM is a very powerful service, guys, right? So it can help you to remove or add permissions, granular permissions to users within instant. Now, whenever you're setting up an AWS account for someone, you can also give him username and password, and you can also do one more thing for him, which is basically you can go ahead and you can enable multi-factor authentication on this guy. Okay, so what is multi-factor authentication? Basically, it's a two-layer security wherein he will not only have to enter the password, but he will also have to authenticate himself using an application, right? So sometimes you will see that companies give you a hardware device which is called a Gemalto, which has a password which changes every 30 seconds. So you have to enter that password in order to log into your account, right? So that is what multi-factor authentication is. So you can configure multi-factor authentication using many ways. So in AWS, what you have to do is go to that user, go to security credentials, and then go to assign MFA device, right? So over here, since you do not have a hardware, what I'm going to do is I'm going to set up a virtual MFA device. Let's click on continue, right? And over here, you can download any MFA device of your choice. So any virtual MFA app can help you. What I'm going to today make use of is there's an app called Google Authenticator app. Okay, so let me show you how that looks like. So one quick second. Let me show you guys my phone. All right, guys, so this is how my phone looks like. So what I'm going to do is I'm going to go to App Store, and we are basically going to download a service which is called Google Authenticator, right? So just download this service, Google Authenticator, and once you open it, this is how it is going to look like. Now what we need to do is we need to click on begin setup, and we need to click on scan barcode. Now this is there for both iPhone and Android systems. Right now what we are making use of is for the Android systems. Okay, so what I'm going to do is I'm going to click on scan barcode, and now the camera app is open. And now what I do is I'll just click on show QR code, and now I'm going to scan this QR code. Okay, so the QR code has been scanned, and now I will have to enter the 2 MFO codes that my app is displaying. So this is how my app has now displaying the codes. Okay, So as you can see, the username, the code automatically has been taken. So let's enter these two codes. So 770971. And now I have to enter one more code, which is displayed over here, which is 686610. So let me enter that. So 686610. I click on assign MFA. So the MFA for the intern account has now been set. Now, what does that mean? That basically means that now when the intern guy will log in, he will basically have to log in using multi-factor authentication. So let's try that out. So we'll just sign out. And now let's again sign back in. So when he's signing back in, the first thing that he will have to enter is the username and then the password. So now MFA code has been asked. So this MFA code will be from our app. So this is our app, this is the code. So what happens if we enter an expired code, right? So let's remember this number 595510, right? So what I'm going to do is once it expires, I'm going to enter this code and let's see if AWS authenticates us when this code gets expired. So this code is expired now, right? Now let me go ahead and enter this code over here. 595510, submit, and you can see authentication information is incorrect. So let's enter this thing again, and this time the code is 937721. I'll have to refresh one, sorry. So it's 447363. So let's enter that. One second. So I think the password is also wrong. So 447363. Okay, so it says the MFA might be out of sync, no problems. So let's enter the code. So 464845, and then this is the code that I can see right now, right? And I'll have to enter one more time. So let's wait. So then now the code is 389494, 389494. And now, as you can see, since I've given the right password, I'm able to sign. So this is multi-factor authentication, guys. So using this, you can go ahead and you can authenticate someone. And if you enter the wrong code, which is a code which is not valid after 30 seconds, you will not be allowed to log in. Okay, so this is what AWS IAM users is. Now we are going to go ahead and understand multi-factor authentication. I've already told you. Now we're going to go ahead and understand the most important, another important feature of IAM, which is IAM roles. Okay, so right now what I showed you was that on my local systems terminal, if I want to make use of any programmatic software or AWS, I basically have to do AWS configure, enter the access key and the secret access key, and then I'm able to use it, right? There is one more feature that AWS gives you wherein you do not require a user. Let's say there is a server that you have on AWS and that server you want to give certain access to. So how can you go ahead and do that? So there is something called as IAM roles. So what I'm going to do is, let me just close intern. Yes. So we'll go to roles and we'll click on create role. So here I'm going to create a role for EC2 servers. Click on next. And let's go ahead and give this role access of S3. Again, S3. Okay, so I'm going to give this guy S3 full access. Click on next, review, and give this role name as EC2 demo role. Okay, this is a role that we are creating. Now, how can you make use of this role? Let me go ahead and show you. So first thing is that this role can only be used on AWS servers. It cannot be used on any other machine. Like for example, over here, the access key and the secret access key that I used, I could use it on any machine, be it my machine, your machine, and a machine on AWS as well. I can use it anywhere, right? But when it comes down to roles can only be used on AWS servers. Now I have to create an EC2 server in order to show you the power of roles. So what I'm going to do is, let's create an instance. Let's create a Linux machine. It will be part of the default VPC, and we'll also have default security group. Let's launch instances. Okay, so this machine is now being launched. Let's name it as demo. Right, so this machine has this IP address. This is the IP address. Let's copy it. So we're going to make use of this IP address to log in to this server. So let's log into this server. Okay. So it says connection refused. Server is still being launched. Okay, server is ready. Okay, we're logged in. Okay, let's type in AWS S3 ls. Okay, it says unable to locate credentials. You can configure credentials by running AWS configure. So if I run AWS configure, it'll ask me access key and secret access key. And that is one way wherein I can give this machine access to a certain user through which he will be able to access the services. But let's say I don't want to use a user. I don't want to give, or I don't want to create a user. I just want to give permission to this server. So how can I do that? I'll go to this server. I'll click on actions. I'll click on instance settings. And then I will, not instance settings, sorry. I will go to security, and then I will click on modify IAM role. Okay, then I can choose an IAM role. So what is the role that I created? I basically created EC2 demo role. Let's select that. Click on save. Role has been applied to this instance. Again, come back to this machine. Type in AWS S3 ls. And can you see, without entering the access key and the secret access key, this instance has now got permission to basically make use of the permission that I gave to this server, right? Now, let's say if I again go back to IAM and I remove this permission, which is basically for S3 usage. Right, so I'll just go to EC2 demo user. This is EC2 demo role. In the permissions, let's say I remove this. Okay, so it says the permissions have been removed. All right, if I go back here, again type in the same command, you will see I will get access denied. Why? Because this particular role does not have the required permission to list the S3 buckets.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above? Comment down your answers in the comment section below. Subscribe to Intellipaat. Now, let's continue with the session.
So let's start with why autoscaling. Now, what would you do if your website's traffic increased and it needs more servers? So let's say you have a website, but your website is getting popular day by day. So you need more servers. So you already have an on-premise setup in your particular garage or wherever your website is running on. So you have that, but every time your website's traffic is increasing, you need more servers. So what you can do for that? So now let's discuss about that. So this will explain us why do we need autoscaling. So now I need one more server for my website. So let's say your website is getting popular day by day. Now you think you need one more server to accommodate the traffic. So you get one server and you configure it manually. Then your traffic is increasing day by day. So now you need a lot of servers. So now you're thinking for a much simpler solution where you will just have to concentrate on your application instead of your servers. So you don't want to go into the IT part of your application, you just want to concentrate on the code of your application. So now so many servers, you will have to spend so much time configuring them. So you might not have enough time to make your application better. So now if it's an on-premise setup, you will have to do everything manually and it will be very hard if you want to scale down. For example, you bought 10 servers for 1000 users. So each server can accommodate 100 users at a time. So let's say one day your traffic goes down to 200 instead of 1000. So now 8 servers will be sitting there idly, still costing you money, but it is not gaining you any money because 2 servers is more than enough to accommodate 200 people, but you have 10 different servers. So now how to solve this? So then AWS came up with an idea to automate the scaling process dynamically. That is, whenever the traffic increases, you'll get more servers. Whenever it decreases, you'll get lesser servers. So how does that work? So let's discuss what is autoscaling, because if I explain it theoretically, you might get the grasp of it, but when I show you the demo, you can understand what exactly is autoscaling. Okay, now let's get started. So now this is why we need autoscaling, because we cannot buy servers and configure them manually by ourselves, and it is very hard to downscale them because they are manual servers sitting there and we cannot just take them and go sell them because we don't need. That will cost you a lot of money. So instead you can use AWS, but how to use that? So now assume that your application normally requires one server for 3 users. So this I was explaining it to you with 100 users. So let me make it simpler with this slides. Okay, now assume that your application normally requires one server for 3 users. So you have a server which is, so you can see this is your web application. You need one server to accommodate this application. Okay, now your web application's traffic going up, your website is suddenly experiencing a lot of traffic one day and one server cannot handle all the requests. So now what do? You bring in auto scaling in between your servers and your users. So now what auto scaling does is, so let's say there are 3 users. So for 3 users, one server. So this server is more than enough. But when you get 3 more and 3 more users, now you will need to have one more and one more server, because each server can accommodate 3 users. There are 9 users currently, and auto scaling will do the job. Whenever there is an increase in the traffic, it will give you more servers. So let's say if there are 6 users, now it will give you only 2 servers, because it will automatically reduce the one server which was available. So before you had 3 servers running for 9 users, now you have 2 servers running for 6 users. This will also decrease your cost of operation, because you only pay for these 2 servers right now. You do not pay for the 3rd server. But if it is a manually set up on-premise server, then you'll have to pay for that as well, because that is using electricity as well. So now this is how auto scaling works. So now let us see what is auto scaling. So AWS auto scaling is a web service. So this monitors your applications hosted on your on-premise server or even the AWS server. Mostly it is used with the AWS server. Okay, now it monitors your applications hosted on the AWS server and adjusts the capacity
according to the traffic for providing steady performance and high availability. This basically means this auto scaling service will monitor the application or the server's running capacity. That is, let's say you have two servers, and whenever the CPU utilization of the servers go above 80%, you need one more server. So if you want to do that, then you can go ahead with auto scaling. Also, let's say you want one lesser server, that is, you have three servers and you want to remove one server. Whenever the CPU utilization average goes below 20%, you want to remove one server, then you can again go ahead with auto scaling. So this is what auto scaling is. So there are two types of scaling. One is vertical scaling and one is horizontal scaling. So in AWS, auto scaling is only available for horizontal scaling. Vertical scaling you can do in AWS, but it is manual. So let's say you have a small instance with 10 GB of RAM. So now if you want to scale it up, then you can increase the RAM to 30 or 50 GB. So if you increase the same instances RAM to 30 or 40 or 50 GB, then that is called vertical scaling, because you're not provisioning more resources, you're using the same resource but increasing the capacity of it. So now coming to horizontal scaling, again you have one server with 10 GB. So now you want more, so you just launch another instance with 10 GB and host your application there as well. So again, whenever the traffic increases again, then again you will launch or you will create one more server with another 10 GB. So now it is equally distributed across three different servers. So horizontal scaling is mostly used in AWS. Vertical scaling is not done automatically. So these are the types of scalings. You can look into this more. Now moving ahead, we've looked at auto scaling. So auto scaling is a service to increase the number of services. So let's say you have 10 servers right now, but how will the system or how will AWS know which server to send the user to? So let's say you have 10 servers. Now there are 1000 users. So let's say the first server is getting 500 users, second server is getting 200 users, third and fourth and fifth servers are getting 100 users. But the last 5 servers, even though they are running the application, even though they can handle the requests, they are again empty without any traffic, because there is no medium to balance this load across. So for that we need elastic load balancer. So now if you use elastic load balancer, you can basically redirect your users to particular domains. In Intellipaat, there is Intellipaat.com as well as Intellipaat.com/blog. So these two are hosted in different servers. So whenever you go to Intellipaat.com, you are in a different server. If you go to /blog, you are in a different server. So now to balance that load, that is, whenever you type Intellipaat.com, you will be taken to a different server, and whenever you type Intellipaat.com/blog, you will be taken to a different server. So that both have the same domain name, but using ELB, using a load balancer, you can do that redirection. You can basically, whenever a user comes in, so if he types that particular address, he'll be taken to one particular server that will be handled by the load balancers. Now let us look why load balancers. I've explained it to you, but still we'll look at so that you understand it even clearer. So assume your application runs on multiple EC2 instances. How do you know that the traffic is distributed evenly among these instances? So this is the question I asked you. So let's say you have multiple EC2 instances, but still you will not know whether the 1000 users are segregated and sent to every single EC2 instance. Some instances might be idle as well. So that's why we need elastic load balancing. Now again, there are 300 users. What if there are 300 users and still running on one instance, but you have 3 different instances right now? So you have 3 instances. Even though you have 3 instances, all the 300 users are redirected to one particular server. So this is not acceptable, right? Because you are paying for the other 2 servers as well. So to do that, we bring in elastic load balancing. So ELB basically receives all the user requests. So let's say you have 100 different servers. So you will not be directly taken to that particular server from your request. First you will be taken to ELB. So now ELB is the single point of entry. So now ELB decides which server it should take you to. So let's say there's a first person comes in, it takes you to the, so let's say this person comes in, it takes him to the first server. Then this person comes in, it takes him to the second server. Then this person comes in, it takes him to the third server or her to the third server. So right now
you can see the traffic is being evenly distributed. It's not the case it will be only evenly distributed. There is also another way of distributing, that is application load balancer. So in that case, what you will be doing is, so the first instance will have a different application, second instance will have a different application, whichever application the user is requesting for. So ELB will redirect that user to that particular server. So even that can be done. Okay, now this is exactly why we need elastic load balancing. Even though you do auto scaling by increasing the number of servers or decreasing it, you need a single point of entry which decides which server to send the user to. Now, so in the simplest terms, elastic load balancers accepts the incoming traffic from its clients. So the clients can be a mobile, an iPad or a Samsung pad, a tablet, a laptop, a desktop. It can be any device which is connected to the internet. Every single request goes to the elastic load balancer. Now the elastic load balancer routes these requests to the targets which the client wants. So basically, I might want to go to intellipaat.com, but another user might want to go to intellipaat.com/blog. So both of these requests come to elastic load balancer, but load balancer will decide path should it send that particular user. So the intellipaat.com user will be sent to the first instance or the first server, because that application is hosted in the first server, and in the second server there might be /blog website is hosted, so the second user might be taken over there. So this is why we need ELB. And what is ELB? So in AWS there are three main types of ELB. There is classic load balancer, there is application load balancer, and network load balancer. So first, coming to classic load balancer, this is basically the most simplest form of load balancer. It doesn't have any criteria. It uses a round robin method. So whenever you refresh it, or whenever a new user tries to come in, it takes him to a different user. There is no particular agenda here. To any server you want. It does not distribute it evenly, but it is a good way of distributing as well. Now coming to application load balancer, as I said, you will have two different applications, maybe in the same server or two different servers. Now you can set up the load balancer so that whenever one particular application is chosen, it will take you to that particular location. If another application is chosen, it will take you to another location. Network load balancer is another type of load balancer which is used to balance the load when a particular port number is taken. So let's say you want to access port number 80 and you're typing that in the website. So let's say www.intellipaat.com :80. So it might take you to one particular server, and :8080 it might take you to another server because they are different. Okay, now we've looked at the three different types of load balancers as well. Now let us see a demo. So this demo, first we'll look at auto scaling, and after looking at auto scaling we're going to look at an ELB demo. So let's get started. So I already have two different servers running, and each server has a different website. So let's check what is the website running in the first server. So it is showing that this is server 1, then second server showing as this is server 2. So to differentiate between these two servers, I have two different websites, server 1 and server 2. Okay, so right now why do I need this? So because I'll have to show a difference between so while doing the ELB demo, I'll have to show a difference, right? Whether it is taking you to a different server every time, or a different server whenever you need to take you to a different server. So that we'll have to see. So first I have two servers. Okay, next I have two AMIs of those two servers. So this is server 1 and this is server 2. So server 1 and server 2. Now coming down to AMIs. Okay, now there is server 1 image and server 2 image. So if I launch a EC2 instance using this AMI, then I will get a server which has the same web page in it. And if I use server 2 image, it will give me a website with this same AMI in it. Okay, so this is how it works. So right now let's start off with the auto scaling demo. So once auto scaling demo is done, we'll move ahead to a ELB demo. Okay, so first we'll have to go to auto scaling groups. Okay, so first let's create an auto scaling group. To create an auto-scaling group, you need a launch configuration. A launch configuration is basically an AMI. So an auto-scaling group should understand which type of an instance that it should launch every time when a particular condition is satisfied. So let's say CPU utilization goes above 80%. So if that is satisfied, one server should be increased. But what type of a server should that be? So I want that server to be server 1. So I'm going to use, so you can see launch configurations over here. These are my older ones. So I'm going to create a launch configuration, create a new launch configuration. I already have an AMI. So server 1 image, and then I'm going to choose the same thing. I'm going to give this launch configuration a name, server 1 launch. Done. Next I'm adding storage, same storage, and I need a HTTP rule. So this is because I have a website and that website is hosted in this port number. I'm clicking review and create launch configuration. So if you already have a key pair, just choose that key pair and create the launch configuration. I already have one, so I'm not going to go ahead and create one. So it's done. So now it prompts us to create autoscaling group page. So we have created the launch configuration. A new instance, whenever it is launched, it should have this is server 1 website. So right now I'm going to create a autoscaling group. So this is going to be called server 1 auto, and it should start with one instance. So I'm going to choose 3 different subnets. So my instances can be launched in 1F, 1B, 1D. Other than that, it won't launch. If you want your instances to be launched in all of the availability zones, then just select every single one of them. Okay, so right now this is what I'm providing. Then do we need to provide any advanced settings? Okay, so health check grace seconds. So I'm going to reduce this to 60 seconds. I'm not going to waste a lot of time over there. Receive traffic from one or more load balancers. I don't need that. Okay, so now we are creating an auto scaling group. Okay, done. So now do scaling policies to adjust the capacity of this group. Okay, now I can have one instance, and if the scaling policy goes above, the maximum I can have is 2 instances. So the thing is, my website needs one instance as a minimum, and at the maximum it needs 2 instances. So let's say your website is a huge website. So at minimum you can have 1, and at a maximum you can have 10, or at minimum you can have 5, and maximum you can have 10. So that's your wish. So I'm going to go with 1 and 2. So I don't need more instances for this demo right now. So you can see here scale group size. This is the name of this particular condition. So average CPU utilization, the target value is going to be let's keep it 70, and I'm going to give 60 seconds. So it will take 60 seconds to warm up after scaling. Okay, that is fine. So I'm adding this, and you can see here average CPU utilization, and whenever the CPU utilization goes above 70, it will automatically create a new instance for me. And so the thing is, whenever it is below 70, I think it will automatically decrease one server, or you can also set up that. So here you can see you can create alarms. So this is to increase group size, this is to decrease group size. So let's create here. So see, read capacity units, write capacity units, I don't need that. So increase group size, I'm going to create one. I don't need to send any notification. So average CPU utilization, if it is greater than 70% for at least 1 minute, at least one consecutive period of 5 minutes, then it will create an alarm for me. So you can see here, so this is to increase and this is to decrease. So whenever this alarm is going to be triggered, it will increase one instance. Whenever this alarm is going to be whenever this particular alarm, which is decrease group size, this is going to be triggered, it will reduce one instance. But I'm not going to do that. So I'm going to use the normal scaling policy itself, because this is much easier to understand at first instead of going into the depth of it. First, whenever the average CPU utilization is above 70, it will increase, and when it is not, it will decrease. So that's it. It is that simple. configure notifications. I don't need a notification. I don't need a tag. And I'm going to create this auto scaling group. Done. So auto scaling group is created, but at first one instance will be created inside your auto scaling group. So if I come down, you can see server launch one. If I go to activity history, and if you come down, not yet in service, launching an EC2 instance. So let me open the instances page in another tab. And here we already have two instances. There should be a third instance which is being created, and you can see it is also running. So I'm going to name this as auto server 1. Done. So now let us check whether this instance, so I have the image of it. I created the launch configuration, created the auto scaling group, but this particular server does not have anything else. That is, I did not go inside, I did not launch a web server, I did not put any website. But if I paste this and hit enter, it should have the server 1 page. So let me hit enter, and it is showing that this is server 1 and this is also server 1. So basically I've created an auto scaling group for this particular AMI, and right now if the CPU utilization goes beyond 70%, then it will launch one more instance. So to do that, I have a sample piece of code, and we're going to use that inside the instance. So first I'll open the instance, and it's the same key pair which is over here, and open. Yeah, so it is open. Now let us check whether Python is installed. Sorry, I think Python 3 might be there. Yes, Python 3 is there. Okay, done. So now what I'm going to do is, so I have a Python script to increase the CPU utilization over here in this notepad. So I'm going to copy this and paste it inside a file which I'm going to create right now. So I'm going to create a file called nano cpuutil.py, and let me just make it bigger and paste it here, save it. Okay, done. So now what I'm going to do is I'm going to run this file, and it's running over here. You can see that. Okay guys, so now the next logical thing we'll have to do is we'll have to sit and wait until a new instance is being created. So until then we're going to monitor this instance. So monitor in the sense we are going to check the CPU utilization. So let's check the current CPU utilization. So okay, let's check for 15 minutes, 1 hour. You can change that over here. Currently it is not even showing because the CPU util is very low. So let's wait until it goes above 70. So 70 is over here. So 70 is in between here. So we'll have to wait until the CPU utilization increases. So this is going to take a time of 5 minutes. So within that, what we are going to do is I'm going to create few let's just begin with ELB, and let's come back and check over here. You can see it's still running. So once this increases to 70%, then there will be a new instance running over here. So until then, let us go ahead with auto scaling. So coming down, you can see here load balancers. I'm going to open this. So for the load balancers, guys, what we're going to do, we'll need another auto scaling group. Basically that is going to be server 2. So let this continue, and let's create one more auto scaling group for our load balancer. Okay, so create auto scaling group, create the launch configuration, my AMIs, server 2. So this is all going to be the same steps. So I'm going to speed up here. So this is going to be server 2 launch. Next, I need SSH rule. I need SSH and HTTP, and review, and done, and create launch configuration. Choose your key pair. So I've created another launch configuration, and now using that launch configuration, I'm going to create another auto scaling group, which is going to be server 2 auto, Again, I'm going to choose 3 subnets. Next, so I'm not going to configure any scaling policies because I've already showed that to you how to do that. And done. I've created another auto scaling group. I'll explain to you why do we need 2 auto scaling groups for our load balancer. So our load balancer will get request from this auto scaling group and also this auto scaling group. Okay, now coming here, if I refresh, there should be another instance getting created, and you can see that over here in US East 1F. Let's check its CPU utilization first of all, and you can see it is around 53. If the CPU util should increase above 70, only then we'll know whether it is working or not, our auto scaling group. So this, let's check which instance this is. And this is server 2. So as I was telling, I created another auto scaling group. So that created another server for me, which is named as server 2. So that is also created, guys. So now we have 2 auto scaling groups with 2 different servers. So our first server, currently the CPU utilization is getting increased and it is at 53.9 right now. And once it goes above 70, we'll get a new instance. So for that, we'll have to wait. So I'm still waiting. It's still at 53.9 and it will be gradually increasing. So we'll only see that when the CPU util goes up. Let's wait for that. So let's also check whether a new instance is getting created or not. So until now, there is no instance getting created. So obviously it is still under 70. And now you can see there is a steep increase to 99.
Just a quick info, guys. Test your knowledge of AWS by answering this question. What are the different types of instances? A. General purpose. B. Computer optimized. C. Storage optimized. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
From 53 to 99. So right now, let's check whether a new instance is getting created, because a new instance will obviously get created, but let's wait and see. Because so right now it will wait for 1 minute whether it is above 70 or not. So if it is above 70 for a continuous minute, then it will give us a new instance, and now you can see a new instance getting created, and I'm going to name this auto server 1 and 1.1. and once it's running, let's check whether it has server 1 inside it. If it is server 1, then we have done it correctly, we have done auto scaling correctly, and we have created another instance for us. We did not scale it, guys, it automatically scaled, and now you can see this is server 1 and even this is server 1. So we've created an instance without creating an instance. That is, we've set up a particular condition. When that condition got satisfied, another instance got created. Simple as that. So let me just stop this. We've done our auto scaling demo. Close this instance. Done. Okay, so now we have one auto scaling group which has 2 instances, another auto scaling group which has 1 instance. Okay, now we have done the auto scaling demo. Now we'll have to start off with the load balancer demo. So let's get right into it. Okay, so before going on to this, I'll have to do one more small edit in server number 2. So we open this and make that edit for you, because we'll have to show a different so we'll have to set up different path for auto scaling group 1 and 2. So let's say if you are typing in intellipaat.com, you will be taken to server 1, and intellipaat.com/blog you will be taken to auto server 2. So that's what we are going to do right now. So for that, we'll need to set up a different path inside auto server 2. So for that, I'm going to open it. I'm going to create another folder over there and also create another simple website inside that. Okay, so as I'm using Apache 2, so all my website is over here. So if I do an ls, you can see index.html. So this is where the file is. So I don't want this file to be shown. Whenever So I'm going to make var, I'm going to create a blog folder. So whenever we are going to create a load balancer, that load balancer will have a DNS name. So when we use that DNS name in our browser, it should take us to the first server, and when we use /blog to that DNS name, it should take us to this particular server. So we are going to do that. I'm going to create a file here, index.html, and this is the server to blog site. So I'm going to save this and done. And now we are set to go with load balancers. Before that, let's just check it once. So now it's showing this. Now if I do a /blog, and it's showing this is the server to blog site. So this is what we're going to do. And first of all, let me just close it. These are just extra. And okay, so I'll just close this as well. Now I have servers, and let's get started with load balancer. I'm going to click on create load balancer. Go to application load balancer, and I've already explained it to you. It will take me to one particular URL first time and second URL whenever I type it in, because I'm going to set it up like that. So I'm going to give it a name as ALB live 1. It's going to be internet facing, not internal, and it's going to listen to port number 80, and I'm going to choose default VPC. And so now what you can do is, if you know in which availability zone your instance is, you can choose those instances. If not, if you do not know, because you're going to be using auto scaling and it can launch your instance in any of these availability zones, you can just click on every single subnet and just click on next. And it's not listening to a safe listener because it is listening to HTTP, not HTTPS, but that's fine. Now select an existing security group. I'm going to select this group. Next, configure routing. So first you'll have to understand we have to create two things. So we have to create two target groups. So whenever we are going to type in just the DNS name, let's consider the DNS name is intellipaat.com, it will take us to one autoscaling group, that is the first autoscaling group. Whenever we type intellipaat.com/blog, it will take us to the blog site of the second server. That is what we are going to do. And for that we need two target groups. So first target group is targeting the first autoscaling group. Second target group is targeting the second autoscaling group. And I'm going to give the first target group a name. This is going to be server 1 target. It's going to be an instance, HTTP 80, and everything else is the same. So here the path is / because it is going to take the index.html file directly from var/www/html. Inside that folder there is an index.html page. That is what is going to show when you type the DNS name. So done. Next, register targets. So I'm not going to register any target right now because I'm going to connect the target group to the autoscaling group. So I'm not going to register any target. You'll just have to remember this and create. So we've created a load balancer, and you can see it also has provided a DNS name over here. So once this DNS server is running properly, we will be able to check out. So before that, so let this be running. Now let's set up the other parts of this particular demo. So we have an ALB which is connected to a target group, but that target group is not connected to any autoscaling group. So to connect that, we'll have to go to autoscaling groups, and server 1 auto is going to be connected to server 1 target. And I'll just close this, actions, edit, and coming down we can see target groups over here. If I click here, it will show me the target group which I already have. So here you can see there is a server 1 target. I'm going to choose it and hit save. So now I've created one part of this particular load balancer. So let's check that. So it's still provisioning. You see here. So what we're going to do is, if I do this, it will show this is server 1, and if I do this, it will show this is the server 2 blog page. So this will work only when this particular ALB is in available state, that is active state. So we'll have to wait for that. So within that, we'll finish the target group work. Okay, now we have connected the load balancer to a target group which is connected to an auto-scaling group. So we've done it for one auto-scaling group. Now we'll have to do it for the second auto-scaling group as well. Now let's create another target group and attach it to the auto-scaling group. Also attach that target group to the load balancer. So create target group. Target group name is going to be server2 target, and here the path is going to be blocked. So this is the target and create. So I don't think this should be changed. I'm just going to keep it slash. I'll show you where to do that change. So now we have another target group done. So now go to auto scaling group. Go to the auto scaling group which you will have to attach this target group to. Click edit, go down and target groups, server2 target, hit save, done. So guys, now we have two target groups attached to each one of these server. So to server2 auto scaling group, we have target group which is server2 target, and server1 auto we have server1 target. So server1 target is already connected to the ALB. Server2 target is not connected. Now we'll have to do that. I'll show you how to do that. So let's go to load balancers. Let me check whether it is active or not. So it is active. So let's just refresh this once.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
So it's still loading. So let's just finish off the remaining work and let's check that again. Now going to listeners. So you can see here, okay, it does not allow traffic. So one mistake we've done is the security group of this particular load balancer is not allowing. So what I'm going to do is, sorry, not this. What security group did we attach? So I'm going to go to that security group and change it. So I'm going to go to the security group, go to inbound rules, and so it is allowing only SSH. I don't need SSH actually, I just need HTTP, and it's going to be anywhere, and I'm going to delete this. So done. So now, yeah, so now I've changed it. Now our load balancer will have access to port number 80. And let's go to listeners, and now you can see, yes, it can listen from port number 80. Let's refresh this again, and now you can see this is server 1 page. So we have successfully connected the load balancer to the target group which is targeting the auto scaling group number 1. Okay, that is done. So now let us see whether the blog page is working. The blog page will not work because we have not attached that target group with the load balancer. Now let me show you how to do that. So go to add listener and port number 80. So the thing is, you'll have to add an action. Coming down, sorry, another mistake. So you'll not have to click add listener. You'll have to actually go to view and edit rules because you already have a listener for port number 80. So now you'll have to click on plus, click on insert rule. Add condition is basically path, and the path is /blog. Okay, so whenever the path /blog is typed, it is going to forward you to the target group server2 target, and that's done. So click here, hit save, and a new rule has been created, guys. So let me just brief it once again before checking out whether the demo is working or not. So we have created a load balancer which is connected to two different target groups. Each target group is connected to a separate auto scaling group. That is, whenever this particular DNS name is typed, it will take you to the first auto scaling group, which is the first server. And whenever /blog is typed, it will not take you to the first auto scaling group. It will take you to the second auto scaling group because we have connected it with target number 2. So I'm going to hit and it's still showing. And again, I did another mistake. This is a simple mistake actually. Let me just get in and edit this and click here, and I'm going to edit this to this and done. Update. So let me try this again, and it's still not working. So server Apache 2 server at port number 80, it's not able to find this particular server, and yes, now it's finding it. And this is the server 2 blog site, and this is the server 1. Whenever you are typing a particular DNS name, it's taking you to a different server. So this is how application load balancers work. You can set up your path accordingly. So now any user who is just checking the home page doesn't need to go to the blog page. So the server is dividing the traffic between two autoscaling groups. One autoscaling group is having the home page, and another autoscaling group is having the blog page. So now maybe there are 1,000 people, 1,000 persons are reading a blog in the Intellipaat sites, and 1,000 people are visiting the course page. So now the course page traffic and the blog site traffic is divided, so that now these servers can handle both the traffics equally and equally well. So guys, this is how you create an autoscaling group and also a load balancer, and then also combine them to work properly.
And then, so why AWS for DevOps? What are going to be the benefits of using DevOps on AWS? So the first thing is fully managed services, guys. So we know why do we use a cloud service? Because we don't want to manage our tools or the VMs we have launched, the data we have stored. We don't want to manage it, or we don't have to install softwares on it. We don't have to do anything. It is all taken care by AWS. They take care of our infrastructure. So that is the first reason, guys, fully managed services. And then built for scale. Because AWS DevOps, you will be using it on existing services like EC2 or Lambda. So when you use on them, they already have a scaling feature within them. So obviously it is built for scale. So you can easily scale it up or down. And then programmable. You can write scripts, you can write shell scripts, you can create a program which you can implement inside AWS developer tools, which can actually impact your DevOps lifecycle. And then automation. So DevOps is mainly automation. So automation is one of the main reasons, and automation is available in everything like Azure DevOps, AWS DevOps, even in GCP. If you are implementing DevOps, automation will be available over there. Or if you manually use DevOps tools to create a DevOps lifecycle, even then automation is required. So DevOps main motive is automation. And then secure. Yes, AWS provides security and it is their first priority. And then pay as you go. Pay as you go model is that whatever you use, you only pay for that, nothing else. For example, you launch a virtual machine using CodeDeploy. So that virtual machine is running for 2 hours and then it gets terminated. So you'll have to only pay for that 2 hours time. You don't have to pay for creating a virtual machine and running it. You don't have to pay a month's fee. You just have to pay the money for that particular 2 hours. So moving on. Now we've discussed what are the benefits of having DevOps on AWS. Now we'll see what are the tools provided by AWS. So these are the 4 tools provided by AWS, guys, and these are the most basic tools. There are still more tools for developing, but these are the 4 most basic tools for creating a DevOps lifecycle. So the first one is CodeCommit, and then CodeBuild, and then CodeDeploy and CodePipeline. So let us discuss these developer tools in detail now. So first let us discuss CodeCommit. So the name suggests that CodeCommit is a version control tool. It is like GitHub. So it is like Bitbucket. It is a version control tool, guys, but it is provided by AWS and it also provides the same features GitHub provides or Bitbucket provides. You can do all of those stuff which is available over there, like committing, pull requests, merging branches. You can do all of it even using CodeCommit. You can also see over here CodeCommit's code commit allows 5 active users per month. So basically this is going to be your private repository. So it allows 5 users per month. If you have a startup and you only have 5 members, you can actually use code commit and you won't be charged even a single rupee. And also you will be given 50 GB of space every month. So for example, our repositories maybe maximum of a size of 1 MB or 2 MB, but 50 GB, they provide 50 GB of space for the repository, guys. And also 10,000 Git requests per month, like pull or push requests. So this is code commit. It is a tool. It is like GitHub. It is like Bitbucket. It is the same kind of tool, but it is provided by AWS. And then AWS CodeBuild. So the name suggests that this tool is for building your application. So it provides a fully managed CI service, that is continuous integration service. It will compile your source code. You can run tests, you can run unit tests, and also provide software packages and store it in AWS S3 so that you can take out those packages and use it to deploy your application. So you can see here AWS CodeBuild, 100 build minutes. That is, if you run a build, it might run for 20 seconds. So like that, you can run any number of builds which come up to 100 build minutes. And also it runs using build.general 1.small compute type usage. So it runs with this, and for every month you get 100 build minutes free. Moving on, AWS CodeDeploy. This is one of the important service, guys. This service is used to deploy your application on any service you choose, like EC2 or Lambda. So it is an automated deployment tool which can deploy services like EC2, Lambda, Beanstalk. So even if you launch Beanstalk, it will be launched in an EC2 instance or Fargate, and also your on-premise setup. So these are the 4 benefits provided by AWS CodeDeploy. So first is automated deployments, and then minimized downtime, centralized control, and easy to adopt. So the first one is automated deployments. Is when you set it up, whenever there is a change in your repository, it automatically runs again, it builds your code again, and it gives it back. So that's what automated deployment means. It doesn't build and it stores, it actually deploys it again. Whenever there is a change in your code, it deploys and the change will be visible in your website. And then minimize downtime. So whenever the code is changed, it takes very less seconds. Your website will be down for maybe 1 to 2 seconds and the change will be on your website, guys. So it minimizes the downtime. For example, when you do it manually, you will have to go to your system or your server where your website is launched and you will have to change your code over there. When you do that, the downtime increases, but using CodeDeploy you can minimize that. So I'll show that in the demo, guys. And then centralized control, you can just use your command line interface of AWS or the management console, and you can control all of the operations happening in CodeDeploy, code commit, and CodeBuild. And then easy to adopt, you can see works with any application, and same experience whether you are deploying it on EC2, AWS or Lambda. That means whatever service you are deploying it to, maybe EC2 or Lambda or Fargate or Elastic Beanstalk, it provides you the same UI with the same experience. So it doesn't change, it is the same thing, but the deployment environment is different. So this is CodeDeploy, guys. And then finally, AWS CodePipeline. So we are going to use CodePipeline. We can use CodePipeline to create a CI/CD pipeline, guys. We can use all those services to do that. So first thing, it is a continuous delivery tool. That's why it is called a CI/CD pipeline. So it is also fully managed by AWS. As I told you, that is one of the benefit. And also you can automate your website or you can automate your application, which is running on CodeDeploy. So when you create a pipeline, whenever there's a change in code, it automatically pushes it to CodeDeploy and the change will be made. So that's how you use CodePipeline, guys. You can see over here, take it as an example pipeline. You have some website over in your source, that is your GitHub. So you build it and you test it using some programs. So after testing it, you can give any number of stages. This is staging. This means you will be seeing this deployed, but you will be seeing it in a IP address which only you might see. You might have given the security group like that. But in production, when it gets deployed in production, then you can view your website using the IP address or the DNS name from any other computer, guys. So this is how you use AWS CodePipeline. And then, so you can see over here, easy to integrate AWS CodePipeline with GitHub or with your own custom plugin. So you can integrate GitHub and CodePipeline easily. You can just click on connect to GitHub. There is an option for that. Or you can use your own custom plugin, like you would have created something in Bitbucket or any other version control tool. You can even use that. And then also it is pay for what you use. It's the same thing, guys. And also there is no upfront costs or long-term commitments. So it is basically free. Whatever services you launch using it, for example, the EC2 instance, so those are charged, not these services like Pipeline or CodeDeploy. And also rapid delivery, which basically means whenever there is a change in your code and it is applied to the master branch, it will be applied to your website directly. And then configurable workflow. The workflow, you will have an UI. You can configure your workflow, how it should happen, which is the deployment server, which is the production server, which is the QA server, or you can mention builds or you can skip builds. So you can create a workflow for your own advantage. And then get started fast. This basically means it's pretty easy. They have a lot of documentation, guys. You can just go on, create your own pipeline in no other than like half an hour. So it takes only that much time. And then it is easy to integrate. You can integrate AWS CodePipeline with any service. You can integrate with even Jenkins. So this is what they say, easy to integrate. So right now let us move on and let us create a CD pipeline using CodePipeline and CodeDeploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I am going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html, destination is this. So this is where Apache 2 installs its index.html file, but we'll be deleting that file and launching our hello world application. So you can see here before install, script/install dependencies and script/server, start server. So I'll show that what actually is there. I'm going to scripts, install dependencies. So in install dependencies, you can see, guys, it updates the instance. After updating the instance, it will install Apache 2. And also, guys, in your script, make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes and it will install the whole software. So whichever software needs a yes, provide a -y, guys. So if you don't provide, it will fail. So it will remove the index.html file in this location. That will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2, but I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. Abspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is we'll have to create a code deploy, guys. So I'll go to code deploy first, and also I'll open. So if I go to code deploy, basically you can see all of this over here. You can see source, repositories. You can actually create a repository, guys. To create a repository is very simple. You can just provide a name, for example, website. And then if you want, you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account, guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is, it's actually pretty simple. And then build is for, as I told you, it is for building your application. But right now I'm launching my website. So I'm going to use only code deploy and code pipeline, guys. So first thing we'll have to do is we'll have to create a code deploy application. So let me click on application. So I already have one. So this is what I tried. So create application. The first thing it asks is your application name. So I'm going to provide it as web server and Apache 2. So web server Apache 2, this is going to be my application name, and here compute platform. This is the most important thing, guys, because here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS. I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance, guys. So now we'll have to create a deployment group. But to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance, guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is it directs or it targets to which instance should this particular code deploy application should deploy the application to. That is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that and also how to install CodeDeploy agent in that, because without installing CodeDeploy agent in your instance, you will not be able to use CodeDeploy for your instance, any instance which you use. So I'm going to use a Ubuntu server, guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using CodeDeploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance, guys. So you can see over here, choose AMI. AMI is Amazon Machine Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server, guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Subscribe to Intellipaat. Now let's continue with the session.
And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance t2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance. You can run this instance for 750 hours every month. So I'm going to go with t2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys, this is the most important thing. You will have to include a IAM role. So why an IAM role? Because the CodeDeploy agent should access your EC2 instance, and also the EC2 instance should be connected to your CodeDeploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 CodeDeploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions. And here you will have to provide CodeDeploy. So you can see Amazon EC2 role for CodeDeploy. You can just choose this and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created, if you want you can create it. If you already have, you don't need to. So I have it, I chose the IAM role. And then also I'll have to enter user data. So what does user data mean? So basically user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually Ruby is required for code deploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my code deploy. After installing that, I'm just modifying my permissions, and after that I'm installing code deploy, which got downloaded. After it gets downloaded, now I'm starting code deploy, guys. After installing code deploy, I'm going to start the code deploy service. Only if it is started, then I can connect my EC2 instance and code deploy. So I'll copy these and enter it in code deploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we've done all of the required things over here, and then adding storage, 8 GB is more than enough. And then you'll have to add a tag, guys. So to add a tag, hit on add tag. Then I want to, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I'm creating this tag? Because I'm going to use this tag to, so I'll have to enter this tag over here so that this code deploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now, I'm going to allow an HTTP rule, because I need HTTP because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now I'll go back. And now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1. And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now, if I just hit name, and you can see many values. My value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance. If I click here for details, you can see over here, and my instance is showing. So this is the instance, and it is showing, so that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. and here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once. If you have a lot of instances running, guys, you can provide half at a time, and after, for example, you have 10 instances, first 5 instances will run. After that, the next 5 instances will start. So if you provide one at a time, if you have 10 instances, first the first instance will get the website, and then the next, and then the next. So it will go one by one. After that, if you give all at once, all of the instances which you have provided, which you have mentioned, will get the website at the same time. So right now I have only one instance, so it doesn't matter if I choose any of these. I'm going to go with all at once. And I'm not using any load balancing, so I'm going to cancel that. And I'm creating my deployment group. So you can see additional settings. Actually, I don't have any alarms or triggers. So I'm just going to go with creating my deployment group. So here you can see I have created my deployment group, and also there is an edit option. So you can edit it or delete it, or you can create a deployment from here. But I'm not going to create a deployment from here, guys. I'm going to create a pipeline which will do that for me automatically. So if I create a deployment from here, every time I'll have to come to code deploy and click on create deployment. I'll have to click on that button, which will create a new deployment every time I change my GitHub code or code in any repository, guys. So instead of doing that, I can just create a pipeline which will do that automatically for me. So right now we've created an application and it has a deployment group, guys. So we are good with that. We've learned how to create a code deploy application and a deployment group, and also how to connect a EC2 instance with code deploy. So you can see it's still initializing. Because we've run some commands, so those commands will be running inside. Normally it doesn't take this much time. So right now it's running, so that's okay, guys. So next, code pipeline. So you only using code pipeline, we're going to connect our GitHub and code deploy. So whenever there is a change in GitHub, so it will be available in our instance. So right now I already created a pipeline which succeeded, and right now I'm going to create a new pipeline for my new code deploy application. So first thing, I'll have to provide a name. I'm going to provide web server pipe. So it will create a role. So it needs a role, it needs a service role, and it will create it automatically. We don't need to create it again and again. And then advanced settings, just click on default location and default AWS management key. Basically, default location means the artifacts, that is the data which will be stored while we run this. That data will be stored in this bucket. So the data will be stored in code line US East 1 and this number. So it will be stored in this S3 bucket, guys. So that is default location. If you have any other bucket where you want to store your artifacts, you can provide it in custom location. And then next, now you'll have to choose your source provider. My source provider is GitHub. So I'm choosing GitHub. And the first thing it asks is connect to GitHub. So I'll have to click on it. It takes me and it connected with my GitHub account because I have already logged in. And then repository, I'll have to choose the repository which I have to deploy. So my website is in this repository, which is also called website. So I'm just going to click on it. And branch, I have only one branch, that is master. And then next. So I don't need a build, guys. Actually, this is a website. There is nothing to be built. It is a HTML page. There is nothing to be built. So I don't need to worry about building. So I'm going to skip build stage. So now you will have to deploy. You will have to click on a deploy provider. So you can see over here, there are various deployment options. You can choose Amazon S3 and launch this website as a static website. You can choose Amazon ECS. You can choose Alexa skill sets. You can choose OpsWorks, even Elastic Beanstalk, and then cloud formations also. But right now, as we are doing code deploy and code pipeline, I'm going to choose code deploy because I already have a code deploy application. So I'm clicking on it. You'll have to choose the region where we created. My code deploy is in North Virginia, so I'm good to go. If I click on this, it should show all of the code deploy applications available in the region. You can see over here web server Apache and a web server Apache 2. So mine is web server Apache 2. I'll have to choose that. And then deployment group. I have only one deployment group. I'm choosing it and moving on. Next. So this is again same thing. Basic stuff. It asks you to review it. You can review it if you want, or you can just move on. So right now, let me see my instance is running. So currently, if I see, so there is nothing available, guys. So let me run this pipeline. So let me create this pipeline. So if I create this pipeline, what do you expect will be available? So there will be an UI with two things, that is the source stage and the deploy stage. So congratulations, the pipeline web server pipe has been created. So you can see source. My source is GitHub and it is in progress. Once it gets succeeded, then it will move on to deploy stage. And you can see over here, you can edit this. You can add more stages, that is more source over here. You can add more deployment stages over here, but I'm not going to do anything. I'm just going to, because I have already created. So right now GitHub has been succeeded. My code has been properly taken. So it took merge branch master from this particular GitHub repository. So right now CodeDeploy is running, guys. So I'll go to details. Let us check whether this succeeds or not. Only if this gets succeeded, then my website will be available. So you can see, oh, my CodeDeploy got succeeded. So right now, if I go over here, you can see all the events happened and also whether it is succeeded or not. If any of this was not succeeded, for example, if this gets failed, so you will see the error code over here, and if you click on that error code, it will take you to a log page which will show what error is available in your code. So you can use that to debug your application. So you can see over here, succeeded, before install succeeded. So before install took 13 seconds. Why? Because in my app.spec.yaml file, you can see before install will install dependencies, and also it will start the server. So as it already showed you in my scripts, so install dependencies will update my application once again, my instance once again. It will install Apache 2. It will also remove the HTML page, index.html page within this location, because I want to launch my application, guys. So then start server will start my Apache 2 service. So only if the Apache 2 service is started, then I'll be able to see my website. So right now, as my pipeline is succeeded, I should see my website, guys. If I go over here, if I choose my IP or my DNS name, if I go over here and hit. So right now you can see hello world to Intellipaat. This is the website which is currently running, guys. So I'll go and show over here index.html, and you can see hello world to Intellipaat. So right now, as I told you, this pipeline should automatically execute whenever there is a change in the master branch. So because that is what we mentioned, whenever there is a change in the master branch in this repository, this pipeline should automatically run. So what I'm going to do is I'm going to change few values over here. So I'm going to just change to hello world, and then I'm going to commit my changes to master branch. So once I commit my changes, if I go over here, it should automatically start. So it is currently in progress because I have changed my code. After some time, you can see there will be a commit ID. The commit, which commit it took, will be present over here. Once it succeeds, that change will be implemented in my CodeDeploy agent. That is my EC2 instance automatically, guys. You can see source update index.html because this is my latest commit. This is the latest commit ID which it took. So you can see it's running, guys. So right now, hello world to Intellipaat. So now it changed to hello world. So this gets succeeded and this changed to hello world, and you saw there was no downtime over here. So this is why you use a DevOps pipeline. This is how you create a pipeline using CodeDeploy and your version control tool. Okay, so whenever there is a change happening in your version control tool, That is, this change, when it is committed in the master branch, once it is committed in the master branch, this pipeline will automatically detect the change happened in your GitHub. It will take the latest commit made and it will run it once again. Once it succeeded, once it is properly run, then it provides the code to CodeDeploy. So CodeDeploy right now will download the contents of this particular GitHub repository. It will store in some location. We do not know where exactly it stores it. It stores it in some location. It will copy the index.html file into /var/www/html. So only if the index.html is available in that particular location, it will be taken by Apache 2 server, guys. So you can see this is how you create a code pipeline and using CodeDeploy and GitHub.
Terraform. So we'll have to understand few things before getting into Terraform. Now, this is my AWS account. Now this is my AWS account. For example, in this case, this guy is a system administrator. And this guy is a system administrator. Okay, who's handling this environment? Who's handling this environment? AWS Cloud. AWS Cloud. Now what happens? He is the one who set up all infrastructures in our cloud environment. All infrastructures in our cloud environment. Like it can be, he is the one who architected the design, and that a cloud application, cloud environment consists of EC2, VPC, and other services like S3, database, RDS, etc. etc. Now here, in this case, let's consider he is working for 4 years in a company. He worked for a company. He worked for 4 years in a company. Then, if he moves out of the company or the organization, if all of these environments, whatever he has set it up, if it doesn't have any proper, if it doesn't have any proper documentation, what will happen? A new guy who's coming, whoever is coming, will not understand what exactly it is, like how the infrastructure is being created, what is the purpose of what is the purpose of EC2 service, how many EC2 services are there, and everything will be in a mess. Basically, but the new guy will not understand how exactly the entire architecture is being designed or created. And the next thing, everything is a manual task. Everything is a manual task in the sense, here if I wanted to create 5 EC2 instances, I will have to create it 5 EC2 instances manually. The same way, if I wanted to create a VPC, I will have to create it manually. And everything is a manual process in creating all of these services using a console. So now whatever we are doing it here is all through console. So whatever I'm creating it here is all through console. Again, if I wanted to create an EC2 instances, what I will have to do? Again, I'll have to go launch an EC2 instance, and again I'll have to create it. Correct? In this case, a new tool called as Terraform comes into picture. It is not a very old tool at all. It was developed in the year 2014, if I'm not wrong. It was developed in the year 2014. Okay. Now, what this tool does it came up with a new concept called as infrastructure as code. Now, what we do, instead of creating it manually over console, so what we do is we create it as a code and we deploy it. Now what happens, anything which you created will have a trace of the code, correct? Like whatever, if I've created 3 EC2 instances, and I'll have a code of it, like so that, and moreover what happens is it brings reusability. Like I explain you all those things, it brings in reusability. So all you do is you write code once and you use it multiple times. And moreover, it brings in automation of infrastructure. Automation of infrastructure. And how this code is being created, so they call it as HCL language. So the whatever the code which we write to create this environment is called as HCL. It's called as HCL language. And how do we do it? How do we create it? And we will see everything step by step. Use of Terraform. Terraform is to code your infrastructure. That is as simple as that. Like instead of creating everything over console manually, so what we do is we create everything using code. And what is that code? And that code is nothing but HCL. An extension of Terraform file is called as .tf files. .tf. Like for Ansible, we save it as .yml file, right? Likewise, any Terraform script will be saved in the form of .tf files. Now, using Terraform, what are all the services we can code? There are lots and lots of services which can be coded using Terraform, like major cloud platforms like AWS, Google Cloud, Azure, IBM, and then other providers, like for example, if you wanted to manage any other softwares. In nutshell, I can show you the list of providers which Terraform supports. Terraform providers. Now, using Terraform, what all we can create it? These many services we can code it. So if I wanted to create, for example, if I wanted to create what are we seen here? Let's consider if I wanted to create an SQL service. SQL server. Using Terraform, we can create it. For example, if I wanted to create a chef cookbooks, I can use Terraform to create it. If I wanted to create Azure Active Directory.
Okay guys, a quick info, if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
Terraform supports. If I wanted to maintain the entire AWS cloud or Azure cloud or Google cloud, everything is done using Terraform. GitHub, GitLab. So whatever we have seen here. For example, let's consider a use case where I wanted to create a user in GitHub. Now what we do, we manually log into GitHub and then we create user, and then we whatever the permission which we wanted to assign it to the user, we will be able to do it. Now using Terraform, we can do the similar setup also. See here, if I wanted to create any GitHub repository, I can create it. How we will create it, let's see. But whatever the manual task which we do using a console, which can be achieved using Terraform as well. And the main purpose of it is to code your infrastructure. How does it benefit? It benefits in such a way that we can keep track of every resource which we configure using Terraform, and also if we wanted to reuse the code. For example, I write the code once like function, and then it can be used later everywhere wherever we wanted to. Is that clear? Now we need to understand few. Yes. Now we need to understand few terms before we get into creating any services using Terraform. Those are here. The first one is resource. Resource is nothing but, for example, if I wanted to create an EC2 instance. Let's consider I wanted to create an EC2 instance. Now, what we define? No, before resource, let me put few other things also. Providers. So providers are nothing but which one we are going to use it. For example, it can be AWS, or it can be GCP, or it can be Azure, or it can be Redis, whatever it is. So what we are going to code using Terraform. So which one it is, and the basic structure remains same, but the functionality wise it differs from providers to providers. For example, in AWS we call it as EC2 service. In GCP it is called as VM. Correct? Those terminology differs, but the core concept remains same. And the next one is resource. What is resource? Let's consider we are using AWS provider. Inside AWS provider, I wanted to create an EC2 instance. In this case, what we do, we create a resource. This is called as resource. Any services inside your provider is called as resource. Whatever we are trying to create is then it's called as resource. Variables. So variables are nothing but an input value which can be defined while writing our Terraform script. Output. Now, output is the resultant value. For example, using a provider AWS, I'm creating an EC2 instance. Okay, let's consider an input value I'm giving. So, if I wanted to create an EC2 instance, what all is required? If I wanted to create an EC2 instance in general over console, what all I need to give?
Just a quick info, guys. Test your knowledge of AWS by answering this question. What are the different types of instances? A. General purpose. B. Computer optimized. C. Storage optimized. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Instance type or whatever it is. Okay, now what we can do is we can input these values while creating our EC2 instance. That is nothing but variable. And the next one is, for example, after creating this EC2 instance, it will come up with some values. For example, instance ID, correct? Automatically it comes up with. Then instance IP address. And these are the output values. So whatever the input values which we are giving it, from that we will get an output value. So that is called as output. Okay. Terraform plan. This Terraform plan is a command. Okay. Terraform plan is a command. In the sense, for example, I have created all of these code using all of these all of these things. I've created a Terraform script. Now I wanted to test that script before I actually apply it. In that case, what we will do, we will run Terraform plan. So Terraform plan, what will happen is it will just do a dry run before we apply it. That is what Terraform plan. Terraform apply. So Terraform apply is a command which is used to apply all your changes. In the sense, if I wanted to create any EC2 instances, first what will I do? I create the Terraform script. Then to test it, I will run Terraform plan. Then if everything looks good, then what we will do? We will we will then run Terraform apply. Then Terraform apply will apply all your changes in the script. Then Terraform destroy. So destroy will delete all your changes, whatever is there in your, delete all your changes. Delete all your changes. And the next one is Terraform init. Here, let's consider we are using AWS provider. Correct? We are using AWS provider. Terraform init. Now here, let's consider this is your machine from where we are running all of these scripts. Now here, all we would have done is installed Terraform into this machine. Now I wanted commands which is specifically for AWS, correct? Only then AWS related configurations will work. In that case, after writing all your code, first you will have to run Terraform init. So what it does is it initialize all modules or all the required modules which are essential to run your script. That is nothing but Terraform init, which initializes all your modules which are required to run your service. I mean, run your scripts. That is nothing but Terraform init. Then what else is required? Very important thing is TF state file. Name itself says, in the sense, TF state file is nothing but a state file which holds all configurations of whatever you have created using Terraform. In the sense, for example, I wrote a script where it creates one EC2 instance. Okay. Now, in the same EC2 instance, I mean the same script, what I'm doing it is I'm creating one more EC2 instance. Now, first one EC2 instance configuration is already added. It's already there. Correct? Now I'm adding second one. In this case, what it should do, it should not create the instance which has been already created. All it has to do is it has to create only the second one. How Terraform will know that one instance is already being created and only the second one has to be created? And in that case, Terraform state file comes into picture. So any configuration which you run, it first checks with your TF state file whether all of these configurations are matching your TF state file and with the current configuration file which you have written. If anything is missed, then it will create the required services. So that is the function of TF state file. Cool. Now, and this is one of the most predominantly or widely used tool in DevOps industry at this point of time. Till now, if like any infrastructure related activities are handled manually, now everything is being coded, and Terraform is one of the important tool which is being used in the industry, and I would really recommend you guys to go through it. So we'll use AWS for our configuration. What is the first step? First step is to install Terraform on your machine. Now what I will do, I will use one of my EC2 instance which I've created. Okay, first what we'll do, let's install Terraform on that machine. So how do we do it? All you'll have to do is download Terraform. You will get the version of it. So all you can do is whichever version you wanted to install. If you're trying it in your local machine, you can use you can download Windows and then try it. Or if you have any Windows machine, just download accordingly. Let me download this one here, copy, and then wget. Okay. Now I've downloaded the file, and then you will see something called as this. Then what you need to do is you will have to move this file to, if it is Linux machine, move Terraform to user local bin. Then what you will have to do, check then cd space user local bin. Then once it is done, Terraform, why it is not running, Terraform to user bin. Okay, so you will have to move, just download the file, just copying it and just writing it here, so that then move the file to move unzip, first unzip, second move the file to move Terraform to user bin. Once it is done, you will be able to, you can check and verify with the command terraform - and the latest version is this one. 12.24 is the latest version which is available. Now we are set with this. Now what is the next step? Let's consider we wanted to create an EC2 instance from this machine. In this case, what we will have to do is, now one logical question. Okay, if I wanted to manage, this account, what is required? For example, if I wanted to manage this AWS account using an CLI, what is required? This is just a logical question.
Root keys.
What is required?
Keys, like in order to like log in and username and password.
Exactly. Correct. Here, so what we need to do is we need a credential where we can manage the account using our Terraform or whatever it is. For that, what we will have to do, first we will have to go and create one user. If somebody is new to the cloud, so what you'll have to do is go to service, IAM. IAM is a service which is used to create your user accounts. Then go to users. Then I'm creating a user with the name Terraform. So all it needs is just programmatic access. So I'm just giving programmatic access and then click next. Here, what we'll do, we'll attach existing policies directly. We'll give administrator access, so that using the Terraform account, it can do anything it wants over this account. But in real time, you will have to come up with a best practice solution where we can actually give access to the console in a better way for any programmatic access. Now let me name Terraform, just Terraform, and then click review, create user, and then let me download this credentials and click the close it. Now here what we are trying to do, so we are trying to create an EC2 instance using this Terraform. So what I'm doing it is, I'm just going to one directory, and then what I'm doing, I'm creating one directory, mkdir, and then as Terraform. And then I'm going into that. I'm creating one more directory, mkdir. I'm creating DevOps. So in this directory only, we will have all our configurations will be in this directory. Correct? Here, what we'll have to create, we will have to create one file called as main.tf. Let me create one file here. In this, let me get into this file, insert. Now, what is the first step? If we wanted to manage, we will have to define provider and mandatory. So now, first what we will do, we will define our provider here. We will define our provider here. Version is nothing but, earlier they were using 2.2 version 2. With 3 they have included so many other new services also, like ECS cluster, so many other services we also included in version 3 with new features. That's it. Now what I'm doing it, I'm just doing this one. That's it. Greater than or equal to 3 and provider AWS version region. Now it is done. Now what we will have to do, we will have to download that provider into our machine. How do we do it? Which command we use that to initialize all modules? Terraform init. So now let's see. Now what it does. AMI is nothing but, like, for example, AMI is nothing but like when we launch an EC2 instance, what we do. Like, see, whatever we are doing it here, we're doing it there manually. Whatever we are doing it here manually, we are doing it there also. Now what we do, we select an AMI here, right? We select an AMI, right? So instead of just selecting over console, so what we do is we give an AMI ID. Every image has an ID. Every image has an ID, and that is what we are giving it here. Okay. Now, what are all the features it supports? Let's consider if I wanted to create an EC2 instance. These are the arguments which you can pass it. In the sense, which availability zone you wanted to pass, like US East 1A or US East 1B, everything. Now at this point of time, what else is required? As mandatory, what else is required? We need key, correct? We will create key name. So these are the arguments which are being passed to the script so that we can create an EC2 instance. Now let's consider key-name, which is nothing but I have one key which is DevOps, and tag is nothing but the name which we generally give while creating an EC2 instance. Now name equal to, let's consider Terraform first instance. Terraform instance. Now our first script is ready. Now what are we are doing? See, this AWS underscore instance is the keyword. Which resource is what which we are creating? Which resource which we are creating here? We are creating AWS instance. This is the name of the resource which we are giving it. Okay, and for this AWS instance to launch an EC2 instance, what all is required? We can pass. See, anything which is given required is mandatory. These arguments AMI and instance type is mandatory. To launch an EC2 instance, these two parameters are mandatory. Other than that, we can customize all other configurations. All other configurations we can customize it. Now, till here we are done. A resource AWS instance, Terraform, AMI we have given, instance type we have given, key name we have given, and then we have given a name for this EC2 instance. Now what is the next step? We will have to Terraform. I already have a key. I already created a key with the name DevOps. So now what it will do, the new instance, whatever we are creating, will be associated with this pin key, correct? I already have a private key of this key pair. Then I can log into that machine. correct? So why do we do Terraform plan? So we run Terraform plan to check whether all our configurations are done properly or not. Let's do it here. Now here, see, it is asking in which region we will have to configure it. You remember? So while configuring providers, there was one option here, region, correct? Which I have deleted it. Region. Now here you can define your default region. US least icon one is Virginia. I have defined it here. Now if I run Terraform plan, now let's run Terraform plan. See, the main thing is if there are any issues with your configuration, when you run Terraform plan, it shows the error. Whatever error you have it in your configuration, it will show it. After fixing it, again, what you can do is you can run Terraform plan. So let me change it. Main.tf access key, access key, access underscore key, then key underscore. Now what will I do? Terraform. Now what it says? It says new mission will be launched. So this will be the configuration. Now what will I do? So how will I create a new machine here? I mean, if I want to apply these changes, what will I have to do? Terraform apply. Now you will have to give yes. The moment you give yes, it says error. No subnets found for the default VPC. Please specify the subnet. Now what happens is, since whatever we have given it here, it tries to launch it on the default subnet. Now what I've done, I've deleted my default subnet. I've deleted, when you look at here VPC, see here I've deleted the default subnet and I've created my own subnet. With that configuration, what it does is, so whatever we have done here, it tries to create this EC2 instance in the default subnet. Now that is what we got an error. See, for launching source instance missing no subnets for the default VPC. Please specify the subnet. Now what we will do? We will go configure main.tf, then include one more configuration, which is nothing but subnet. Let's check whether it is right. Subnet underscore ID. That is the argument which we will have to pass. And this is the subnet ID. Now again, what we will have to do after making changes, Terraform plan. Okay. Now if you look at here, it will say that subnet ID is this one. Correct? Earlier, when you look at, you would have not seen that. Now Terraform apply. Cool. Now we can see that one resource is added. Let me go to my EC2 instance. Earlier it was one instance running. Now it is two instances. Second instance, this instance is running here. And whatever configuration which we have given, it has come up. Now you can see one thing here. It did not have any public IP address. Correct? It did not have any public IP address. Now in this case, what we can do, what is required, if I wanted to connect to this machine, a public IP address is required. Correct? Now let's create a public IP address for this machine and then attach it to it. Now in this case, Terraform apply is already done. Earlier you will not see one file called as terraform.tf state. After you apply your first change, this file will get created, terraform.statefile. What is the purpose of this terraform.statefile? It maintains all the information about your configuration. It maintains all the information about your configuration. This is your instance ID. See, this is your instance ID. The statefile maintains all information about the resources which are configured using Terraform. Now let's see. Now what is the second requirement? Now what is the second requirement? If we wanted to attach any public IP address to that machine. If you wanted to attach any public IP address of this machine. Okay. Now in this case, what we wanted to do, if I wanted to create a public IP, there is a resource called as AWS EIP. Correct? There is a resource called as AWS EIP. Just go there. Here, what will I do? Create and so this. Now what we are doing here, we are creating one more resource, which is nothing but AWS EIP, and let's name it as Terraform instance EIP. Now this is nothing but getting a value of, this is how we get values of other machine. So whatever we got it here, see the whatever we are getting it here, the what is this syntax is the older version syntax. Here we don't need that. This all of these things are not required. Now what I need, to which machine we are attaching this elastic IP? To this machine, correct? And what is the resource name? Which is AWS underscore instance. And what is the name of the resource? What is the name of the resource? Which is Terraform. It is Terraform. And ID, to understand that, we will have to understand a bit about what are all the values it results. Let's consider, where is the EC2 instance? AWS instance. See, attribute reference is nothing but what are all the values it can result. In the sense, see, what are all the values you get it in your TF state file. Terraform.tf state file. Here, what is that? ID, correct? See, this value it results from this configuration. What is that configuration? This value holds this machine. Now what we are doing it in this configuration, I'm creating one more service which is nothing but EIP, and this will after creating that elastic IP, it has to be attached to this EC2 machine. How do I know that to which EC2 machine I will have to attach? Using this configuration value, AWS instance.terraform.id. This ID actually holds what? The value of that machine, which is nothing but this one. This one, the value, this one, let's consider if I run this value, what will happen? Terraform plan. See what happens. It creates an EAP and then attaches and gets attached to that EC2 instance. Same way, what will happen? Let's see if I give that value. I'm replacing it with. So these are dynamic values which we can get it. How do we get it? AWS underscore instance underscore dot terraform dot id. Now again, if I run terraform plan, see, we got the same value. Now let me apply it. Terraform apply. Last for check, select yes. Now you don't see that public IP, any public IP is being attached here. Now if I refresh it here, see, one IP got attached to it. And this is how it works. Now, if using the same concept, what we can do is we can create any number of services which AWS provides with bit of fine tuning that is required. That is required according to a configuration, the best practices which we follow and everything. Now, see, it becomes more effective or more powerful as and when it goes, like when we start talking about other configurations. You'll understand the actual purpose of it. Now let's talk about something called as variables. Now the same concept is same. Variable is nothing but if you wanted to input any variable, then we use concept called as variable. Correct? If you wanted to pass any, if you wanted to pass any values from the user or get values from the user, then we define variable. And how do we do it? There are multiple ways to do it. One, what you can do is you can create a file called as variables.tf, whatever it can be. I'll give it as inputs.tf. You can create the same method also. I created with the name inputs.tf. So what we can do is, let me get some values from the user. Why do we have to give this value automatically here? If I give, everybody can use it, right? So what we can do is, we can define it as a variable so that it doesn't being exposed. Now what I will do, I will define it in such a way that give var dot access underscore key and then var dot secret underscore key. So in this case, after defining it here, so go to inputs.tf file. We will have to define that variable. So how do I define that variable? Key name is variable and give the name variable. Let's, what is the name I'm giving? Access underscore key. Then open bracket and then go close bracket, and then name is, we will have to define which variable type it is. Now what variable type it is? That is string. And there are different types of variables also, like list of string, maps of string, tuple of string, lots of other things are also there. At this point of time, let's not get into that level. So the value which we require there is string. And how do we do it? Type equal to string. That's it. The same way, we have one more variable also, secret underscore key, type equal to string, and then close it. Now with this, what happens? Now let me check the configuration, whatever I have done, Terraform plan. See, now here it asks for the value. What is the value? var.access key, which I will have to give it from, and then secret value.
Okay, so we've seen that. First of all, before going into the certification details, I'll explain what is AWS DevOps. So AWS is a cloud platform. Fine. DevOps is a methodology to automate the software development lifecycle. So how does these two come together? So first of all, to create software, to build software, you need tools. To release software, you need tools. For every single process, you need certain tools. So using AWS, you can launch servers in which you can build your software, you can test your software, you can push your website into, and you can host your application over there. You can do every single operation in AWS. So now an AWS DevOps engineer will specialize in using AWS for DevOps. That is, this particular person who is an AWS certified engineer will know how to use AWS, how to use DevOps, and also other tools. So under DevOps, let's say tools like GitHub, then there will be tools like Jenkins, there will be tools like Nagios for monitoring, Xdeploy, and then there is Chef, Puppet, Ansible. So this particular person should know all these tools as well as AWS services. Only then he can or she can clear the examination. So that examination's code is DOP-CO1. So this is the code for the AWS DevOps certification. So I think you would have understood. So DevOps is basically automating the software development lifecycle. Now, if you're doing that with the help of AWS, then you can go ahead with the AWS DevOps certification.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Subscribe to Intellipaat. Now, let's continue with the session.
Okay, so first of all, what is it? The AWS Certified DevOps Engineer -Professional. So this is DOP-CO1 exam. This is intended for individuals who perform a DevOps engineer role with 2 or more years of experience provisioning, operating, and managing AWS environments. So I'll tell you this. First of all, you cannot directly become a DevOps engineer because you should have worked in the IT profile. Only then you can move ahead with DevOps engineer, because every single role in DevOps engineer requires certain experience on using GitHub or other DevOps tools which that particular company is using. Okay, so that's what I wanted to convey over here. Then, so to clear the DevOps certification, what should you go through? So they have content domains and their weightings. So there are 6 main domains which you'll have to concentrate on. So this is not randomly taken values. These are taken from the official guide provided by AWS. So for the AWS DevOps certification, so you can check that out online. You can just type in AWS DevOps certification and you'll get the official site. You can go in and download the guide and check it for yourself. So under this, there is SDLC automation, there is configuration management and IAC, which is infrastructure as code, monitor and logging, policies and standards automation, incident and event response, high availability, fault tolerance, and disaster recovery. So that percentages are the weightings of questions in the examination. So if there are 100 questions, there would be 22 questions from SDLC, 19 questions from configuration management and infrastructure as code, and the others. So I think you got the idea of how this works. Okay, so first of all, SDLC automation, which is basically software development lifecycle automation. You should know all the tools required to do that. It may be in AWS as well as other DevOps tools like Docker, Kubernetes, Jenkins. Then configuration management and infrastructure as code. So configuration management basically deals with tools like Chef and Puppet. So you use this to manage the configuration in all the servers. So let's say you have 10 servers having the same application. So all the 10 servers should have the same configuration, right? So you can use a tool like Chef. So you can create a master and all the other servers will be your slaves. So what you can do is, this master should be connected with all the other slave servers. So once that is connected, you can upload the configuration file to the master. So the master will take care of making sure all the servers connected to that are having the same configuration. So this is what configuration management like simply is. This is not the whole thing. And then infrastructure as code, where you can create a JSON file which you can use to create a complete architecture. So if I go deep into this will take a lot of time. I'll give you a basic idea about this. So first of all, SDLC automation, configuration management and infrastructure as code. Then monitoring and logging does not come third. Third comes incident and event response. So I'm saying third in the percentage, that is the weightings. Okay, so incident and event response in the sense there would be a lot of troubleshooting. So because you will have to, whenever there is a bug, whenever the application is down, you should know how to respond to that. You should know how to solve that. So that comes under. And then comes high availability, fault tolerance and disaster recovery. So first of all, high availability in the sense the application which you are hosting online should be always available for the customer. It should never go down. Even if it goes down, it should come back up immediately. Fault tolerance and disaster recovery. So when you have an application hosted in a particular availability zone, there is a calamity happening over there. Let's say there is a huge storm and the data center is completely off and you cannot host your application over there. So you should have a replication of your entire application in another availability zone for this particular issue, so that when the application goes down over here, we can start off the application over there. So basically recovering from a disaster. So once this availability zone comes back up, you can go back to using this. And then comes monitoring and logging. So you need to know how to monitor all your essential tools required for SDLC automation. You should know how to monitor your complete software development lifecycle in a single go, and also logging. And then comes policies and standards automation. So this is mostly theoretical. You should understand the policies and the standards of automation of the company you are in, as well as the regulations. So the thing is, to automate any software, you will need certain policies that this should happen and this cannot happen. So you'll have to figure out what is that, and then you'll have to work towards that. Okay, so these are the basic content domains and their weightings for the AWS DevOps certification. So now the recommended AWS knowledge you will need to clear this particular certification: 2 or more years of experience provisioning, operating and managing AWS environments. So to clear this particular examination, the recommended AWS knowledge given by AWS themselves is you should have at least 2 or more years of experience working on AWS. And then comes experience developing code in at least one high-level programming language. So only if you know to program and create applications using it, only then you can easily understand the SDLC process. So that is required. Experience building highly automated infrastructures, that is creating again an SDLC lifecycle which is automated, or a DevOps lifecycle. Then experience administering operating systems. So this is basically monitoring when there is a problem, troubleshooting it, and understanding of modern development and operation processes and methodologies. So this is, let's say you're using a certain tool and in the market there is a new tool which will make that process much simpler. But if you don't understand how it works, then you cannot take that up. So let's say you're using Jenkins and suddenly there is a new release called Jenkins 2.0 which makes the CI/CD process much simpler, and you're still using Jenkins for SDLC lifecycle, and sometimes that might not be appreciated because you should adapt to the modern development. And if there's a much easier way of doing something, you should move towards that. Okay, so this is the recommended knowledge. Now the DevOps learning path to attain the AWS Certified DevOps Engineer professional certification. So the thing is, there is no prerequisites to take this up. You can directly take up the AWS Certified DevOps Engineer certification, but it is not recommended because it's a very advanced examination, and the recommended path to get the certification is provided by AWS. So you can check this path out. First of all, you can take up Certified Developer Associate or the SysOps Administrator Associate certification by AWS and get that certification by clearing those exams. So you can do this in your first year or second year of your job. So once you did this, you can either take up a DevOps engineering on AWS or advanced developing on AWS courses, so you can learn how this actually works in the real-time industry. And then you can take up a practice exam on DevOps engineer before taking up the actual exam. So DevOps engineer exam readiness exams are pretty cheaper than the actual exam, so you can take that up, and if you're confident enough, you can give a go to the AWS Certified DevOps Engineer and you can get the certification. So this is a simpler path, but this will take a lot of time to achieve if you're going to take up this particular path. Okay, so you can take this up. Next, the examination details for the AWS DevOps certification. So you can see here the examination is multiple choice, multiple answer. It is a professional type. Then the delivery method is you can take it up in a testing center. And right now, as you know about the COVID situation, there is an online proctored exam as well. You can take that up. And then time 180 minutes to complete this particular exam. Cost $300 USD. if you're taking it up. If you're taking the practice exam, it is 40 USD. You can also, as I told you, this is for professional. If it is an associate certification, which is AWS certified developer, the cost of the examination would be 150 USD and the time would be 130 minutes, and practice exam cost would be 20 USD, and the languages available will still be the same, which is English, Japanese, Korean, and simplified Chinese. Okay, so these are the exam details and this is the learning path. Let's move ahead to AWS DevOps Engineer, roles and responsibilities. So first of all, so let's say you have learned everything you need to know about AWS DevOps Engineer. Then if you want to become an AWS DevOps Engineer, you should understand the roles and responsibilities of one. So first, who is the AWS DevOps Engineer? So an AWS DevOps Engineer will design and develop automation using AWS and other DevOps services to support the CI/CD workflow or the DevOps workflow. So to be very simple, an AWS DevOps Engineer will create an SDLC, that is a software development lifecycle, using AWS and other DevOps services together. Okay, so we saw this, who is a AWS DevOps Engineer. So I think you would have understood that point very easily. Now coming to this, now let's check out some AWS DevOps job descriptions. So these are two job descriptions which I found and we'll compare this. First of all, this is an AWS DevOps Senior Engineer job description. So at the very beginning, you can see, don't process any profiles without the below must-have skills. So these skills below, which are must-have, so not must, good to have is not a problem. It's not required that you know those tools, but in any job description, you should know the tools which are provided in the must-have section. First of all, code repositories, GitLab is must, Runner, Bitbucket configurations tools. Then you should know Docker, you should know Chef, Ansible, so Bash scripting, Groovy. Then under AWS services, you should know ECS, Forget, Lambda, SNS SQS, CloudFront, CodeBuild, configuring CloudWatch, Secret Manager, Active Directories, Serverless Application Model, Service Catalog, Kubernetes. And then comes Jenkins, Maven, NPM automation, and then Rundeck. So these are for CI/CD, those are AWS services, those are the Docker and code repositories. So these are some of the must-have tools, and you can see there are a lot of AWS services and DevOps tools involved together for an AWS DevOps Senior Engineer. And then this again is an AWS DevOps Architect. So under this, you can see the job description is pretty simply provided. First of all, implement and stay abreast of cloud and DevOps industry best practices and tooling. So this is basically theoretical. You should know how the cloud industry and the DevOps industry is moving ahead. And then also you should be an expert in these three tools: AWS CodeCommit, AWS CodeBuild, AWS CodeDeploy, as well as AWS CodePipeline. So these are developer tools provided by AWS. These are not separate DevOps tools. So I just wanted to show two different JDs to show how much it varies. So basically it is dependent on the company you're applying for. So in this company, right, if you want to take up, you should know all of these tools. If you want to take up in this company, which is GroupSoft, they have provided you should be an expert in 4 main tools: CodeBuild, CodeCommit, CodeDeploy, and CodePipeline, and also good communication skills. Obviously that is needed for any job. Okay, so we've seen the job descriptions. You can go ahead and check out job descriptions in various job portals like Indeed, Glassdoor, let's say a Monster. You can check that out. You can figure out what tools you know and what you'll have to learn, and then you can register for an application. Okay, so you've seen that. Now, what are the companies which are hiring DevOps engineers right now? So before taking up this session, I looked into companies who are currently hiring for DevOps engineers. So it's pretty simple. Just go to Google and type AWS DevOps engineer or Azure DevOps engineer or just DevOps engineer, because any DevOps engineer would require to learn cloud tools. So if you're just searching for a DevOps engineer role, even then you should understand the basics and know how to work with AWS. So these are the top companies which are hiring currently for DevOps engineers. Anyone who is aspiring for a DevOps engineer job, you can go ahead and apply for those jobs and go ahead with the interview. So there is SAP, there is Paytm, Amazon, Oracle, and Dell who are currently looking for a DevOps engineer, but You should remember this. All of these companies require an experienced DevOps engineer. So do not apply if you're fresh. Don't apply if you're a fresher. Just take up a developer post or any other software engineer post, then move ahead with DevOps engineering. That would be a better career choice. Okay, so now we've seen that. Now you might also have a question of what are the services should I learn, because we saw various different job descriptions and it had contrasting tools which you'll have to learn.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
So let's see what are the main tools you'll have to learn. First of all, in AWS DevOps, these are the top developer tools provided by AWS themselves. So you learn code commit, code build, code deploy, and code pipeline thoroughly. So learning these tools is important. Then comes the AWS services and the DevOps engineer tools. So under AWS services, learn every single tool if you want to, but there are hundreds of tools and you cannot learn all of them. So take up 10 or 15 services which are extremely important for a DevOps engineer role, such as EC2. EC2 is basically a server creator. You can create servers, maybe Linux or Windows. And then Amazon RDS is a relational database service where you can create databases. That is also required for any company who develops software. And then Amazon EBS is for volume. Amazon Direct Connect is for connecting the cloud, so the cloud architecture with your on-premise setup. Then there is S3 for storage, Elastic Load Balancing for balancing your website's load. And then Route 53 for routing. It's basically a DNS server. And then Amazon VPC is more of an AWS concept in which you can create virtual private cloud. That is creating an network within the cloud so that all the resources within that particular cloud is not available for the public. And Elastic IP address is basically an IP address which you can use to locate your server, which is the EC2 server. Okay, so these are the services in AWS, and you can see the DevOps engineer tools. First of all, you'll obviously need to know a source control tool, either it's GitHub or Atlassian's Bitbucket. So let's say that company is using the Atlassian ecosystem, go ahead with Bitbucket. If not, GitHub is the most commonly used version control tool. And then configuration management, Jenkins is a CI/CD tool as well. And Jenkins and Puppet, Chef, you can take that up. Ansible, learn all these tools. For cloud, learn both of AWS, Azure. If you want, you can learn GCP as well, or take up any one of these cloud tools, either AWS or Azure, and go ahead with that. And then comes Docker, LXD for containerization, and for orchestration comes Kubernetes. So containerization, again, you'll have to go ahead and learn DevOps, only then you can understand these concepts. But just remember this, you'll have to learn Docker, very important. Kubernetes is very important. Okay, so these are the services which you'll have to learn if you want to become an AWS DevOps engineer. So AWS, given that, you should learn the AWS services as well as these 4 tools. And then you should also learn other DevOps tools like GitHub, Docker, Kubernetes, Jenkins, Puppet, Chef, Nagios, and there are so many DevOps tools which you can learn from. But again, don't learn all of those tools. Take up certain tools and learn them thoroughly.
How to crack AWS interview. So let's say, how do you do the preparation and how do you appear for the interview? Okay, so now as I say, the first thing is the hands-on and the services that I was talking about. For storage, you need to know S3, you need to know EBS, you need to know EFS, and remaining storage gateway on a high level, it's okay. Remaining, you don't have to focus so much. On the database side, Aurora, Elasticache, DynamoDB, and RDS. These 4 are very, very important. Remaining, you can skip. Okay. Security, identity, and compliance. AWS IAM is very important. Remaining, it's not needed that much. If you're from application background, AWS WAF, you can go through it, but don't dig deeper into it. Make sure you are very much comfortable with AWS IAM. Okay. All right. So cryptography PKI not needed at all. Machine learning not needed at all. And management and governance. Okay. So here there are few topics like auto scaling, very important, cloud formation, very important, cloud trail, CloudWatch. CloudWatch is again, there's no concept, you just see how to monitor stuff. Cloud trail is again very simple, not that complicated. Okay, CloudWatch, CLI for AWS admins, very, very important. Command line interface, you need to know that. AWS config is important. Okay, and remaining, it's not needed that much. You can go through AWS OpsWorks on a high level. Okay, in migration and transfer, go through database migration service, go through schema conversion tool on a high level. And on the networking and content delivery, CloudFront, you do not need to know CloudFront in detail, just know what it does. That should be enough. Okay, Route 53, very important. Elastic load balancing. AWS VPC, super important. These two, end user computing, front-end web service, not needed. Analytics, if you are from analytics background, if you are from database administration background, then analytics is important. So which other things you should know? Amazon Athena. But again, before this, you should know big data development, right? Amazon Athena is important. Cloud search, data pipeline, Amazon EMR, Glue, Kinesis, and Redshift. So if you are from database administration, big data administration, or data warehousing backgrounds, then these are needed. If you are not, don't even bother. For application integration, Amazon SNS, SQS, very, very important. Just go through Amazon MQ and state functions, what it does. Again, on a high level of SWF. If you skip SWF, that is also fine. You don't have to bother about SWF. Business applications not needed. These are not needed. Yeah, satellite robotics, quantum computing, blockchain, AR/VR, these are not needed at all. Billing and cost management, go through it. Again, this is not for certification. This is needed for you to work on AWS. Management console, again, this is not a topic. You already know AWS management console. If you want to become an AWS developer, SDKs are very important. If you are from Java background, you should know AWS SDK for Java. If you are from Python background, you should know AWS SDK for Python. If you are from .NET background, you should know AWS SDK for .NET, so on and so forth. These are not needed, at least right now. Okay, so these are the important topics. Again, this is step number 2. So how do you broaden your experience on AWS? So that is step number 2. Okay. No one is going to ask you, how do you launch an EC2 instance? No one is going to ask you, how do you create a security group? People will ask you, let's say, how do you create what are the things that you have to take care of when you create a 3-tier architecture, when you create an application, or when you're creating a VPC for a 3-tier architecture? Okay, again, this is a simplified question. Again, the question would not be so simple. So for example, let's say the first question, you have an application. I hope you can see this. Let me increase the size. So you have an application deployed in AWS, but because of security reasons, all of them have been launched in private subnet. NAT gateway can't be used too. How do you get software repositories to those machines? Now, if I tell you the answer, so real-time questions, you cannot find those in documents, right? So these are the things that you can answer only on practice. Okay, all right. How do you get the IP address of an application load balancer? What do you see when you try to do so? Okay, how do you get the IP address of an application load balancer? NS lookup is the command. So again, this will not be asked in the interview. Okay, so the question here is that try NS lookup. So the answer for this one is bash and host. Go to the architecture of load balancer, and then you'll be able to understand why we'll see multiple IP addresses for the load balancer. Okay, all right. Question number 3. You have a retail application set up on AWS. Electronics section is in VPC 1 and home appliance section in VPC 2 in the same region. The payment component needs to communicate to both the mentioned sections. Where do you place those? Tell me the application design for the scene. Okay, so this is an application design question. This actually, see, don't get too much nervous about this last line. Tell me the application design. Actually, they are not asking for application design. If you see, they're asking for the network topology. So one is in VPC 1, electronics is in VPC 1, home appliance is in VPC 2. The payment component needs to communicate to both the mentioned sections. Where do you place those? It's a network topology question. So if you know VPC well enough, you'll be able to answer this. So the answer is, can anybody try? 3-tier is not the answer, no. VPC 3 in the same region, exactly, VPC peering, correct. So you create another VPC where the payment gateway or the payment component would be placed. VPC 1 would be paired with VPC 3, and VPC 2 would also be paired with VPC 3. So see, this is not an application design. So even though the question says, tell me the application design for the same, the answer is actually a network topology. Correct. All right, design a disaster recovery system of an application with 2 hours of RPO and 12 hours of RTO. So what is RPO and RTO? This is there in the self-paced video. So if you know what is RPO and RTO, it will be very easy to answer this. Now, what is RPO? RPO is recovery point objective. Just let me give you a high level idea about this question. Now there is a very common question. Okay, you can get this question literally. This is one of the favorite questions of the interviewers. So RPO is recovery point objective, which means that the time, sorry, how much data can you afford to lose? So that's what RPO says. 2 hours means you can lose data for 2 hours. Okay, so that is point number 1. What is RTO? RTO means how long will it take to bring up the DR region. Okay, so application on the DR region. Okay, so now how do I answer this? So first is RPO. When you talk about RPO, you need to know what an RPO is. As I said, it is about just a second. So it is about the time that you can afford to lose data. So they are talking about data. And where do you place data? You place data in RDS databases. Correct. Now, there's an answer that you can deploy backup for every 2 hours. No, that is not feasible. What if your database size all combined is, let's say, 10 terabytes? Do you think you can take backup of 10 terabytes in 2 hours? Not possible. What do you do? That answer has been discussed in the training. And the answer is read replica. So if you create a read replica, you get an RPO much lesser than 2 hours, because your application lag is somewhere in seconds. So create a read replica of your database systems. Okay, what about application? How do you take backup of application? That is also covered. So application, you have AMIs, right? So what are AMIs? AMIs are the so basically you launch an EC2 instance, you install all your applications, you put your code in the EC2 instance, and then you create an AMI. And you can copy an AMI across to another region. So what do you do if it's 2 hours? Then application does not have any data. So on the application side, you just have to make sure that your AMIs are available in the DR region also. Okay. And on the DR region, then you launch the application just the way you launch on the primary side.
Just a quick info, guys.
Test your knowledge of AWS by answering this question. What are the different types of instances? A. General purpose. B. Computer optimized. C. Storage optimized. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, question number 5. Even though you have set up auto scaling, new instances are not starting. What could be the reason? No, the workloads have reached its limits. Let's say one of the answers is it has reached its maximum limit. So let's say minimum in the auto scaling group, minimum number of EC2 instances is 2, and the maximum is, let's say, 5. It has already reached 5. Again, this is typically in a certification question, but it is asked in the interviews also. Okay, you have an S3 cross-region replication, but you see that the objects are not being replicated. What could be the possible reasons for the same? Think about it. What is connect metric? There's nothing called, correct metric or alarm not triggered. Alarm for what? Choosing of regions, permission issue, yes. So see, when you set up AWS cross-region replication, you don't have to do anything. No alarm is needed, no matrix is needed. S3 does it automatically, as long as the S3 service itself has an IAM role attached to it, which can put object in the other bucket in the other region. So this is a permission issue. So this is not, so as you can see, this is not an S3 question as such. This is mainly IAM. So if you practice in a cross-region replication, there's an option when you set up cross-region replication where it says create a role. So if you have not done hands-on, you'll never know that exists, right? So that's why hands-on is needed. Okay, question number 7. Your organization has IBM DB2 databases installed on hundreds of EC2 instances. As they are not managed services, DBAs are needed to maintain and govern those databases. How do you allow DBAs in your corporate network to log into those DB2 database servers? Okay. IAM is not the answer. No. It's DB2 on EC2 instance. So you want DBAs to, on your corporate network, to connect to a database which is on EC2 instance. How do you do that? SSH is the answer, yes. So basically, what do you do? Through the internet, definitely no. So that is not the answer. So what do? You create a, let's say, Bastion host, SSH into the Bastion host. And from Bastion host, you SSH into the DB2 EC2 instances where DB2 database servers are installed. Okay. Again, as you can see, this is more on network topology again, because it talks about how to allow people from your network. So now, what about Bastion host and your network? Now here, you need to know that, okay, the AWS VPC would be connected to on-premise data center either using VPN or using direct connect. That's all you need to know. Okay, so the interviewer might ask, how do you make sure that the connection is there between your AWS VPC and your on-premise data center? So you say, okay, you can use VPN or direct connect. Now, no one expects you to set up VPN or have experience in VPN setup or direct connect setup. But you should know, okay, these two can be used. Okay. Question number 8. You have an application like Instagram to upload your photos by users. Users take selfies using their mobile phones and upload those to the application. We are planning to host the application on AWS. How do you design such application? What AWS components would be needed? Now, see the question again. It talks about how do you plan to host the application on AWS? How do you design such application? This is not an application design question, remember that. To read the question carefully, it says, users take selfies using their mobile phones and upload those to the application, which are hosted on AWS. What AWS components would be needed? So you can use either Lambda or EC2 instance. Now, the photos are uploaded by the application rather than the users directly. So the if the application on EC2 instance, either on Lambda, let's say that is on EC2 instance, Instagram Live application can be on EC2 or Lambda also. Now the question is, how do you upload the photo from EC2? How EC2 uploads the photo? See, the application is on EC2. It can be in Python, it can be Node.js, it can be Java. How do you upload that to S3? Now, again, here the question is about permission. So you need to have an IAM role attached to the EC2 instance, which will be used by the application to upload the photo in S3. So what AWS components would be needed? It would need S3, it would need AWS IAM, it would need AWS EC2 or AWS Lambda. Of course, auto scaling, load balancer, VPC, all those things are also there, which are implicit. You should tell those things implicit from my side. Okay. Question number 9. The global application is hosted on AWS and its database is placed on RDS. Now the problem is that the number of users is increasing and you are getting performance issues ever since. What are the troubleshooting steps and how can you solve the problem? Mention the steps. So the troubleshooting steps is typically for the database administrators. This is not for AWS architects, but how do you solve the problem of the performance issue? So monitor CPU usage again. Why do you need to monitor? Because you already know that there's a problem. Monitoring CPU usage will not help you solve the problem. It will tell you that there is a problem. Auto scaling, you cannot do auto scaling on RDS. RDS is vertically scaled. You cannot scale it horizontally. So what would be the solution? Think about it. Say again, the situation or the service has been discussed in the training. How to use load balancers? So if you use load balancers, load balancers would be for application, not for database. So read replica is the answer, which can be used to scale. What about writes? Anything else? Okay, so can't you use SQS for this as a shock absorber in between the application and the database? So use SQS, and SQS can scale unlimitedly. You do not need to bother about SQS scaling. What do? You put the applications there, use it as queue, and then use applications and ask those applications to load the data on the databases at its own pace, which is comfortable for the database. So as I was saying, so can't you do that? So these are the things that you have to see. As I said, you have to know to use all the services collectively as an architect. That is the role of an architect. Okay. Storage auto scaling will not help solve your purpose. Storage is for storage. How does it solve the problem of user? Right. Okay. Now, question number 10. You are working for a customer which has AWS resources. For security reasons, customer is not willing to create AWS account for vendors. How to get access to the customer's AWS account in such scenario? So let me rephrase the question if you have not understood it. So let's say I am a customer and you are working for me. I don't want to create an account for you I don't want to create a user in my account. Okay, but you have an AWS account and you want to work for me. How do you do that? I don't want to create any IAM user in my AWS account. So how do I enable you to use my AWS resources? Because that is needed, because it'll be, let's say you're a service provider. For me, how do you do that? IAM is high level answer. What is AWS organization is not the answer. The purpose of AWS organization is completely different than what I'm saying here. See, you are a service company. I'm a product company, let's say. You need to know the usage of the services. Okay, so if you don't know the usage, again, how do you know the usage enough? You need to practice rigorously. You need to face a lot of issues, lot of errors. Then only you'll be able to learn. Okay. So that's all.
So our first question asks us, can we explain the Git architecture? Now, this is fairly an important question, reason being, only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right, so let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. And this is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code, you committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right? Now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server, right? So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right, so this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address, 1 second. Yes. So we'll just copy this address and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes and the message should say changed background. All right. So the changes have been committed and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert, and then give this ID which you just copied, okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything and then you can see that the commit has been reverted. So now I have not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed, right? Now, if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right. So guys, this is how you can do a revert on a basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right. So with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things, all right? Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically a disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. And basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right, so this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right, so let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically, there are softwares like hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond, or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically, once you've virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with the given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Subscribe to Intellipaat. Now, let's continue with the session.
For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? It will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system, but in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command, right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay, so we have come back to our AWS server. Let me clear the screen. All right, so if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a docker exec -it and then bash. Docker exec -it and then I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a ps-aux, these are all the processes which are running inside the operating system right now. Right, but let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the dollar prompt. That we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Docker file used for? What do you basically use a Docker file for? So a Docker file is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Docker file, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right. So let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it-p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container. -it. This is the container ID, and then container ID, and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right. So for doing that, let's create a Docker file. And what I want to say is in the image shhar/web app, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay. This is where I want to add it. And inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing like you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with. In those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system. You'll have to see the operating system on which it is running and a host of other things, right? It has a lot of dependencies and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of auto scaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git. Like we took that example, when you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins runs. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right. But before going ahead, let's see what is the architecture for this kind of a thing. All right. So this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on AT80. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay. And what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that, I'll say sudo docker rm-f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the Docker file as well. Okay, so we created a Docker file inside.
Just a quick info, guys. Test your knowledge of AWS by answering this question. What are the different types of instances? A. General purpose. B. Computer optimized. C. Storage optimized. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using, if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right. So what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a Docker file. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job. And that is it. So inside this, I will have my Docker file, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we are building this Docker file and we're naming this created image as Jenkins, and then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins, and if everything goes well, it will say last delivery was successful. Okay, so any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I come back to my terminal, do an ls, and let me go inside DevOps IQ, and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay. And I change the image from 2 to 1.jpg, and that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to a remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85 and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check. What are the port that we have specified? So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3. And now let's git push origin master, enter the credentials, great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master, enter the credentials, everything has been pushed, job is getting triggered, job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome guys, so we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have, say, around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the 3 top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team, what softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right, but if you talk about the architecture or the working or the life cycle of how this actually works, on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right. So in a passive check and in an active check, the queue is going to be there, but it's only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right. So our next question says, create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to without, going inside the client system, we'll have to install a particular piece of software inside it. Okay, so let me quickly do an SSH into my AWS machine. And what I'm gonna do is I have a slave machine which I have already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay, now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here, I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified apt. Basically I want to use the apt package to install Apache 2, the latest software. Okay, now what I will do, I will type in Ansible -playbook, and I'll type in apache.yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group, It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now, what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And For those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Okay guys, a quick info: if you're looking for an end-to-end AWS DevOps certification training, Intellipaat provides an AWS Certified DevOps Engineer training course, and those details are provided in the description box below, and you can go check it out.
So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.